If you already work with data in Excel and want to add more power to your data analysis and evaluation using Python, then this is the course for you. Frank is a data scientist and he will teach you how to use Python to work with data.
Hi everyone, my name is Frank Andrade and this is my Python course for Excel users. I created this course to help Excel users move from Excel to Python. But why Python? Well, in Python we can do most of the things we will do in Excel, such as working with data, making charts, and pivot tables. But that's not all. We can use all the power of Python to automate tasks, work with large data, and do a lot of things thanks to the thousands of free libraries Python has. On top of that, Python can help you become a better data analyst or get into new fields like data science. I divided this Python course for Excel users in 3 modules. In Module 1, I'll teach you all the Python core concepts you need to know for data analysis. Then in Module 2, we'll learn Pandas. Pandas is a Python data analysis library that will help us do most of the things we can do on Excel. In Module 3, we'll put into practice what we learned in this course by creating a pivot table and visualizations such as line plots, bar plots, and pie charts. Remember that in the description, you will find the files, code, as well as a free PDF Python cheat sheet I created for this course. There, you will find the concepts, methods, and functions we will see in this course. By the way, I'm Frank and I will be your instructor in this course. So let's get started. To download Anaconda, we go to anaconda.com and click on Get Started. Then we choose the last option, Download Anaconda Installers. And then we have here the different Anaconda installers. So there are Windows, Mac, and Linux. So in my case, I'm going to choose Mac and I'm going to choose the 64-bit graphical installer. So now I'm downloaded Anaconda, and once it's downloaded, I'm gonna click on it and a message will pop up. You just have to click on allow, as I'm gonna do right now. So just click on allow and then click on continue until the installation starts. So I just click continue and then agree and then continue, and it's gonna start installing Anaconda. In case you're on Windows and you're installing Python or Anaconda for the first time, make sure to check the first box you see now on screen. So I'm going to speed up the video now. Okay, the installation is almost done and now it's telling me that Anaconda works with PyCharm, and now I'm just going to click on continue to finish the installation. So I click on continue and then we'll see just a summary of what was installed. And now I'm gonna close this window and I'm gonna open Anaconda. So I'm going to locate the icon. It's a green icon, this one that you see here. And I'm gonna open Anaconda. I'm gonna wait a couple of seconds and let's see what was installed. So here we have the Jupyter Lab and Jupyter Notebook, which are widely used in data science. So I'm going to launch Jupyter Notebook. So here it's opening Jupyter Notebook. Let's give it a second. And now we open a new notebook with Python 3. So Python 3 was installed too. And that's it. In the following videos, we'll learn how to use Jupyter Notebook. In this video, I will introduce you to the Jupyter Notebook interface. Jupyter Notebook is an open source web application that allows us to create and share documents that contain live code, equations, visualizations, and text. This is the perfect text editor for doing data cleaning and transformation, data visualization, and data analysis. This is why Jupyter Notebook is widely used in data science and also machine learning. As you might remember, we installed Jupyter Notebook in Python with the Anaconda navigator, and this means that we already have installed some popular libraries used in Python for data analysis. By the way, one of the alternatives of Jupyter Notebook is Jupyter Lab. Both are similar, but we're going to use Jupyter Notebook in this course because of its simplicity. So let's open Jupyter Notebook, and to do that we have to click here on the launch button. So I click here and now we wait a couple of seconds, and now we have here the interface of Jupyter Notebook. So I'm gonna maximize this, and by default Jupyter Notebook opens the root directory of your computer. It's a good idea to create a folder where all your Python scripts will be located. In my case, this folder is called Anaconda scripts. So I click here, and now I can navigate through the folders. And the folder I'm going to use for this example is this one that says My Course. And here we're going to create our first Python script. To do that, we click here on the new button. So click here, and we have to click on the first option that says Python 3. There are other options like text file, folder, or the terminal, but we're not going to use these options in this course. So click on Python 3. And now we have a Python script powered by Jupyter Notebook. So here on the right, you can see that it says Python 3, and also there is the Python logo. And on the left, you can see here the Jupyter Notebook logo and also the name of this Jupyter Notebook file. We can change the name of the file by clicking here on Untitled. So I click here and I can change it to, let's say, example. So I write example and I click on rename, and now we renamed this Jupyter Notebook file. Alright, now let's navigate through this menu bar that we have here in this Jupyter Notebook file. So the first option is the file, and here we can create a new notebook with Python 3. So if we click here, we're going to open a new Jupyter Notebook file from scratch, as we did before. Then we have the open, and in this case we can open a Jupyter Notebook we created before. We can also make a copy to a Jupyter Notebook and then change the name. We can save a Jupyter Notebook file and rename the file as we did before. We only click here and rename the file. Then we can save all the progress we make in Jupyter Notebook. For example, after writing many lines of code, you can save all the progress you make by pressing Ctrl S or Command S on Mac, and you're going to create a checkpoint. And later you can revert to a previous checkpoint by using this option here. So here you will see many checkpoints and you can revert to a previous checkpoint. By the way, by default, Jupyter Notebook makes saves every 30 seconds or maybe 1 minute. So there is no need to press Ctrl S every time. So keep that in mind. Then we have other options that I don't use so much, like print this Jupyter Notebook or export the Jupyter Notebook file to HTML or PDF and so on. Okay, now let's see the second option that says edit. And here we can edit all the cells we have here in this Jupyter Notebook. By the way, here, what you see here on the screen is a cell. So we can edit with this edit option. For example, we can cut cells, we can copy cells, paste cells above, and delete cells. On the right, you can see the shortcuts that we're gonna see on the next video in detail. And well, you can check all the edit options that you can perform on Jupyter Notebook here. Then in the view option, we can toggle the header, the toolbar, and also line numbers. So here, if I click on toggle header, the header is gonna disappear. And if I click on toggle toolbar, this toolbar disappears too. Also here in toggle line numbers, we can show here line numbers. So if I write anything, we can see that it says 1, 2, 3, and so on. And I'm not gonna use this for this course. I'm gonna leave it with the default options. So here I'm gonna revert to the original option, so without line numbers, and I want to show the header and also the toolbar, but you can personalize it as you want. Next, in the insert options, we can insert cells above or below. We only click here, and well, we're gonna see the shortcuts later in the next video. Then we have the cell options. We can run cells or run all the cells in this Jupyter Notebook file. And then we have the kernel option, and a kernel is a computational engine that executes the code contained in a notebook document. When we open Jupyter Notebook, a kernel is automatically launched, and we can interrupt this kernel by clicking here. So by interrupting, we can pause the execution of a code. We can also restart everything and do more things here. Sometimes, for example, I interrupt the kernel when a line of code or a cell takes too much time to execute. And well, you can do the same here with restart or interrupt. Then we have the navigate option that doesn't actually have anything here, widgets that I don't use so much, and well, help that I think it will send you to the documentation of Jupyter Notebook, and you can read it if you want. Alright, here then we have the toolbar, and here you will find some shortcuts of the menu bar that we've seen before. For example, here you can save and make a checkpoint. So here I click here, and as you can see here, it says checkpoint created or something like that. Yeah, checkpoint created and the time that it was created. Then you can here with this plus button insert a cell below. So I click here, and as you can see, we can insert a cell below, and also you can use shortcuts, but that I'm going to show you in the next video. Then we can cut selected cells with this button. We can copy a cell with this button, and also we can paste cells below. Also, we can move a cell above or below. For example, I'm going to write anything here, and this cell, I can move it above with this button or below, as you can see here. Then we can run this code. For example, I can write the number 1 and then run the code. And as you can see here, the code ran and it shows the number 1. And well, those are some of the frequently used buttons in the toolbar. And that's everything you need to know about this Jupyter Notebook file. Okay, now before finishing this video, I'm going to show you some other options that you can find here in the Jupyter Notebook interface. In here, you can see that there are some other options. So right now we are in the Files tab, and we can change to the Running tab here. And here you can see all the currently running Jupyter Notebook processes. For example, we can see here the Jupyter Notebook file we created and that we opened. So you can recognize that a Jupyter Notebook file is open or that is running because here the icon will be in green. So here, if we go back to the Files tab, we can see that this Jupyter Notebook file, which by the way has the IPYNB extension, is in green. So the icon is in green. So this indicates that the file is running and well, it was opened. So here we can see that it's open and we can shut down this file. And this is different from closing this file. For example, here I have the file, and if I close this file, here we can see that the file is still running. Here we see running and is in green, and in the running tab it still shows up. So if we want to shut down this file, we click here and it says that there are no notebooks running, and we can see here that the notebook has a gray icon. Alright, then we have the Clusters tab, and this tab I don't use so much, and actually it doesn't show anything here. And then we have the NB Extensions tab. Here you can install any extension to personalize Jupyter Notebook even more, and we're gonna see some cool Jupyter Notebook extensions in the next videos. And by the way, this NB Extensions tab doesn't show up in some versions of Jupyter Notebook, but we can easily install it. And we'll also see how to install this NB Extensions tab in the next videos. Finally, we have this box that shows our directory. So here this folder indicates the root directory. So if I click here, we are not in the root. And if I click on the folders, Anaconda script, and then my course, I go to the folder where I was before. And that's it. These are all the things you need to know about the Jupyter Notebook interface. Okay, in this video, we're gonna see some cell types and cell modes in Jupyter Notebook. So first, we're gonna open the Jupyter Notebook file that we created in the previous video, which is this one, example.ipynb. So we click on it, and here we have the Jupyter Notebook file opened. And here by default, we have this first cell in command mode. And we can say that this is command mode because here this blue color indicates that the cell is in command mode. And when we are in command mode, we can do things outside the scope of any individual cell. So basically all the tools we see here in the toolbar, we can apply it in command mode. Also in command mode, we can apply some shortcuts that I'm going to show you later. And for example, if we want to see the shortcut window, we press the letter H in command mode, and we can see the keyboard shortcuts here. So here you can see all the shortcuts and all the shortcuts that you can apply in command mode. Now I'm going to close this one. And also you can apply different shortcuts, like for example, if you press B in the command mode, you will see that there is a new cell, because B is the shortcut that introduces a new cell below. Now if we press enter, you're gonna see that the color is gonna change to green. So here we have green color, and this green color indicates that we are in edit mode. And the edit mode is for all the actions you will usually perform in the context of the cell. For example, introducing text or writing code. So here I can write, say 1, 2, 3. So if I write 1, 2, 3, and then I click on this run button, I'm going to run this cell. And as you can see here, I run this first cell. And also after running the cell, you can see that we are again in command mode. So to go to edit mode, we press enter again. And now we can edit the numbers we introduced. So for example, I can write 4, 5, 6, and then run again. And here you can see that the output shows 1, 2, 3, 4, 5, and 6. By the way, if you try to use the shortcuts in edit mode, it won't work. Here I press enter, and now I'm on edit mode. And if I press the letter H, you can see that nothing happens. We don't have the shortcut window. And if I press the letter B, you can see that we don't insert any cell below. This happens because those shortcuts work only on command mode. So to escape this edit mode, we have to press the escape button. So I press escape, and now I'm again in command mode. So if I press H, we have here the keyboard shortcut. And if I press B, you can see that we inserted a new cell. And that's it for the command and the edit mode. Now we'll see the cell types in Jupyter Notebook. In Jupyter Notebook, there are 3 main cell types, and we can see all of them in this drop down here. Right now the type of this cell is code, so here it says code, but if we press here, you can see other cell types like markdown and row NB convert. So we're gonna see first the code cell, and it already has the check. So this one is a code cell. So now I press here, and now, well, it's in code cell. If I press enter, I'm in edit mode, and here I can introduce any code I want. So here I can write any number, 999, and if I press Control Enter, we can see that here this is the input, and here we got the output of this code. We're gonna see how the code cell works throughout this course. But now it's time to see how the markdown cell works in Jupyter Notebook. So here I'm going to this cell, and now I'm gonna change the cell type. So I press here in the drop down, and now I select markdown. And in the markdown cell, we can introduce any type of text we want. For example, we can introduce titles. So if I delete this and press the hash sign, we can get title. So 1 hash, it means title. So here I press space, and now I write title. Now I press Control Enter or this run button to run this cell. And here we got the title. By the way, you shouldn't get this 1 number because I just modified the default behavior of Jupyter Notebook. So mine enumerates the titles and subtitles, but in your case, you will see only the word title. And if you want, you can introduce also subtitles here. So for example, I'm gonna insert a new cell with this button, this plus button. And now I'm gonna move this cell up with this button here. So I press this. And now I'm going to change the cell type from code cell to markdown cell. So I go to the drop down and select markdown. And by the way, you can change the cell type also with shortcuts. So if you're in command mode, you can press the Y button to change to code cell. So I press the Y button, and as you can see here, it says in, and this in with the square brackets indicates that this is a code cell. So here I can press enter and introduce any code. Here I introduce numbers and press the run button, and here you can see that we have an input and an output. So this is a code cell. But now we can press the M button to make this cell a markdown cell. So now I press M, and here we are in command mode. So now we can get this markdown cell. And here you don't see the in word with the square brackets anymore. So now I'm going to edit mode. So I just press here, or well, you can press enter to go to edit mode. And now to introduce a subtitle, I'm gonna write double hash sign. So I press hash sign twice, now a space, and now I'm gonna write a subtitle. So I write subtitle. I press Control Enter or the run button to run this cell, and we got here the subtitle. And we can also introduce text. So I'm going to introduce a new cell with a plus button, and you can also do it with a B shortcut. So I'm going to do it with a B shortcut right now. I press B, and here I got this new cell. And we can move this with this button here. And now we have this cell in the position we want it. So here I can introduce text by converting this cell to Markdown. So here I choose Markdown. Now I press enter to go to edit mode, and here I can introduce any text. For example, I can write hello. I press Control Enter, and now we can see that we have here this text. And finally, the last type of cell is the row NB convert. And this type of cell is not evaluated by the notebook kernel. So if we convert this code cell to a row cell, this cell won't be evaluated by the notebook kernel. So let's try here. I press row NB convert. And now we can see that this looks like a plain cell. And well, this type of cell is not used that often. Actually, we're going to use only the code cell and the markdown cell in this course. And that's it. In this video, you learned the cell types and cell modes in Jupyter Notebook. Okay, in this video, we're going to see some common shortcuts used in Jupyter Notebook. And we're going to start with the F shortcut. And by the way, to use this shortcut, you have to make sure you're in the command mode. And to verify you're in the command mode, make sure that the cell has this blue color. Okay, now that you're in the command mode, you can press the letter F and you're gonna see this find and replace. So this first shortcut allows us to find a word in a cell and then replace it with another word. For example, I can write here the word hello, and here it found the word hello inside this hello word sentence. And now I can replace this word with the word, say, hi, for example. So here I write hi, and now in red we can see the match, and in green we can see the word that we're going to insert. So here let's click on replace all, and now you can see that it doesn't say hello world anymore, but now it says hi world. So now I press Control Enter, which is another shortcut to run the cell. So you can press here on run, or only press Control Enter to run this cell. So I press Control Enter, and now we run this cell. And another way to run cells is to press Shift Enter, but in this case we're going to run and insert a new cell below. So now let's see, I press Shift Enter, and now here it ran this cell because now it says in and 3 inside square brackets, and here we can see that we have a new cell. Okay, now another shortcut that is often used is the Y and M shortcut. So now this cell is a code cell, and if we want to make this a markdown cell, we only have to press the M letter. So we press M, and this is going to be converted to a markdown cell. And if we press the letter Y, this is going to be converted to a code cell. And also you can change the heading here. You can make the heading bigger or smaller. So here I'm going to locate this cell, and now to make this one smaller, we can press the numbers. So if we press the number 2, we can see that this one gets smaller, and if I press number 3, the title gets smaller, 4 smaller, and so on. So as you can see, the more hash signs, the smaller the text. So here I'm going to delete these hash signs, and one hash sign represents the biggest font size, which is the title. So now I press Control Enter, and now we have this in heading 1. But if I press number 5 and then press Control Enter, we can see that now this cell has heading 5 and it's smaller. So now I'm gonna revert to heading 1. So I press 1 and then Control Enter. Okay, now we can navigate through the cells by pressing on the up or down keys on our keyboard. And as you can see here, we can navigate through all the cells here, or we can also press with the mouse, we can press on the cells we want. Okay, now we can insert a new cell above by pressing the A key. So if I press A, we get here a new cell above. And if I press now B, we get a new cell below. Now, if I press X, we're gonna cut this cell. So I press X and you can see that the cell was cut. And now if we press V, we paste that cell below. So I press V and now we got this cell. And if I press Shift plus V, we get the cell pasted above. So I press Shift and V and we get this new cell above this cell I have here. Okay, now I can delete cells by pressing D twice. So I press D 2 times and as you can see here, the title disappeared. So now I try it again and we don't have the title anymore. But now if we press the letter Z, we can undo those changes. So let's undo what we did before. I press Z and we get here the title back. Okay, another useful shortcut is the Control S that allows us to save the changes we made in this Jupyter Notebook file. So I press Control S and you can see here that says checkpoint created. So I'm gonna press again Control S and here it says checkpoint created and here also says the time. And that's it. These are some of the most common shortcuts used in Jupyter Notebook. But you can see other shortcuts by pressing the letter H. So I press H and here you can see more keyboard shortcuts, or you can also go here to help and then go to keyboard shortcuts here and you get the same window. So here you can see a list of shortcuts for command mode and also for the edit mode. You can see the description of a shortcut and also how to do it in your operating system. One of the typical ways to get started with a programming language like Python is printing a simple message. You can write any message you want, but it's traditional among coders to start with a hello world. So let's try it. Let's print our first message using the print function. The print function prints a message to the screen. So I'm going to write here print and then I'm going to open parentheses. Every time we use a function in Python, we have to open parentheses. Well, in this case for the print function. And as you can see here, the functions get a green color in Jupyter Notebook. So that's how you can identify them. So inside these parentheses, I'm going to write the message. So in this case, it's going to be hello world. So this is our first message. Now, to execute this first line of code, we have to press Control and Enter, or Command and Enter if you're on Mac. So I'm going to press this, and as you can see here, we have our first hello world. Another way to run this first cell is pressing here on the run button. It's going to have the same effect. So I pressed and it ran. So as you can see here, it says in, which it represents a code cell, and this is a markdown cell as we've seen before. One of the advantages that Jupyter Notebook has is that it allows us to print the last object in a code cell without specifying the print function. So for example, here I can print this hello world without writing this print function. So I'm gonna copy this hello world message that it's inside quotes, and I'm gonna run this code. So just Control Enter, and as you can see here, we have this message printed. So this is one of the advantages that has Jupyter Notebook. If you do this in another Python IDE, it won't work. So here you can try yourself. You can write any message you want apart from the first hello world. You can try with your name. So we write print, then parentheses, and we open quotes because we need to define a string. I'm gonna tell you about strings a little bit later, but just so you know right now. And here, for example, I can write my name. So my name is Frank and I can print my name. Then I can print also numbers. So I print my age, 26, and it's gonna work too. And besides writing code, you can also add comments. Comments are a useful way to describe what we're doing in our code. So here we can use comments we just have to write the hash sign, which is this one. So you write hash sign and then you write the comment. In this case, I'm gonna write my name and I'm gonna say printing my name. So we know what our code is doing. Here in the first message we wrote, we can also add a comment. So we write hash sign and then we can say printing my first message. As you can see here, the comments also have a different color. So far we have 3 colors. This color for the comments, green color for the functions, and red color for the string. This is just a useful functionality most text editors have that allows us easily read code. Okay, now let's see some data types in Python. Every value in Python is an object. An object has different data types. Let's see the most common data types in Python. So, one of the most common data types in Python are integer and floats. Both are numbers, but integers are numbers that can be written without a fractional component. Just like, for example, the number 1, number 2, 3, 4, 5, and so on. So all of them are integers. And we can check this value or this data type by using the type function. So this is our second function we're going to see. So we write type, then parentheses, and we run this code. And as you can see here in the output, it says int, which represents integer. So this is an integer. Okay, the second type of data I want to show you is float. Floats are numbers that contain floating decimal points. So basically 2.3, let's say 1.2, 5.4, and so on. So here we have another type of data, and let's check out if these are actually floats. So we use type and then parentheses, and we run this code, and we see that we have float. And just like on Excel, you can perform math operations in Python using these numbers. So some operations you can use are addition. For example, you can say 1 plus 2 and then execute this code and you get 3. You can use subtraction, so 4 minus 1, execute, and you run this code and you get 3. You can also do multiplication, division, exponent, and more in Python. But now let's see the third data type that we will see often on Python, and it's the Boolean. Boolean are true or false values, and we can check this using again the type function, and we write type, and within parentheses we write, for example, true, and we run this code and we see that we got the bool, which represents a Boolean data type. So we can also write type, and in this case false, and run this code and we get bool again. So this is Boolean, and we're gonna use Boolean often when we use conditionals. Okay, now the fourth data type I want to show you, and it's very common, is the string. A string represents a series of characters, and in Python, anything inside quotes, either single quotes or double quotes, is a string. So let's see them. Actually, we already see one kind of string here when we printed this hello world, and you're actually familiar with this, but we're gonna see it again. So to create a string, we have to open either single or double quotes. So in this case, I'm gonna use double quotes. So you see it now. And now I'm gonna write any message. So I'm gonna write, for example, again, hello world. And again, to verify the type, we can use the type function, parentheses, run this code, and we got the str that represents a string. And one cool thing a string has is methods. We can apply different functions to strings as we will do in Microsoft Excel, for example. However, in Python, we use methods. A method is a function that belongs to an object. To call a method, we use the $sign after the object. let's see some string methods to change the case of the text. So here I'm gonna write again hello world, but now I'm gonna use some string methods. So I write hello world, and in this case I'm gonna use the upper method to make this uppercase. So I'm gonna use the print function, but actually we don't need to use the print function because, as I told you before, in Jupyter Notebook we don't need to use the print because it automatically prints the last line of code. So since this is the only line of code in this cell block, it's gonna print it automatically. So we just run this cell and we have hello world in uppercase. So as you might expect, now we can also change the case of the text. In this case it can be on lower case or title case. So I'm gonna just copy and paste this twice, and here I'm gonna write, instead of upper, I'm gonna use lower and then title. So you can see how it's gonna change the case. So here I'm gonna run and let's see what happens. So as you can see here, it only printed the last one because, as I told you before, it only prints the last one. And if we want to print the three of them, we have two options. So we can maybe here cut and paste on each cell, or what we can do is to print each of them. So here, for example, I can do print here, and I can do the same for them. So instead of using more cells, we can print all of them. And here we can print this one too. Actually, we don't need them. We don't need it because it's gonna print the last line. But just for the sake of this video, I'm gonna print the three of them. So here I'm gonna run this code, and as you can see here, the first, it has an uppercase, the second has lowercase, and the third has a title case. So that's how you do it on Python. Other string method that you can find in Python is the count method. So I'm gonna delete this, and actually this one too, and we're gonna see this now. So first I copy this, and now I paste it here, and here I'm gonna use the count, so the count method. So I write count, and then here I open single quotes, and I write the letter that we want to count. So here, for example, I'm gonna write the L letter, and what this string method is gonna do, it's gonna count how many times this L letter is included in this string. So as we can see, there are two L's, so it should set 2 times. So I run this code, and actually it's 3 because there are 2 in hello and 1 in world, so I was wrong. And here another string method that you can use is the replace method. So we can replace one letter for another. So here, let me copy this, and I'm gonna paste it here, and instead of writing count, I can write replaced. So here, the first letter that we're gonna see here is the letter that we want to replace. So in this case, I'm gonna change the L with O, and the second letter is the letter that you want to put in that string. So I'm gonna use the U. So I'm gonna change every time that an O appears here in the string, we're gonna replace it for a U vowel. So let's try it. So I run this code, and now it says, well, hello world, but with U. And these are some of the most common string methods in Python. Okay, now it's time to learn something that you're gonna see often in Python, which are variables. Variables help us store data values. In Python, we often work with data, so variables are useful to manage this data properly. A variable contains a value, which is the information associated with a variable. To assign a value to a variable, we use the equal sign. So let's create a message that says I'm learning Python and store it in a variable called message_1. So here I write message_1 and we set it to the string I'm learning Python. So I open double quotes and here I write I'm learning Python. So this is string, we've seen this before, and this is the variable, and we assign this value to the variable using the equal sign. Now I'm going to run this, and as you can see, nothing happens, but actually we just assigned that string to the variable message_1. Now if we want to obtain the message I'm learning Python, we only have to type the variable name and then execute that code. So I'm gonna copy and paste it here, and then we run this code, and as you can see, by running this cell we obtain the content inside the variable message_1. We can create as many variables as we want, just make sure to assign different names to new variables. So let's create a new message that says and it's fun, and store it in a variable called message_2. So first I write message, so message and _2, and then we set this equal to open double quotes and write and it's fun. This is my second variable, and I'm gonna run this cell. So as we can see, the string was assigned to this second variable, and if I copy and paste this variable here and run this code, we can see that the message it's there. By the way, if you're using single quotes instead of double quotes as I'm using in this video, probably you had the following issue. So here I'm gonna copy this one and paste it here so you can see what I'm talking about. So let's say you're using single quotes instead of double quotes, so you get this. This is a problem that you will have when using single quotes, because in the English language we use these apostrophes often. So a simple way to deal with this is using double quotes. So as you can see here, if I use double quotes, everything is okay, everything remains as a string, but with single quotes it doesn't happen. So only the I gets this string, but the rest it doesn't get a string value or the string data type. So just make sure you use double quotes every time you have these apostrophes, and that's it. Okay, now let's put these two messages together. So message 1 with message 2, I want to put them together. So this is called a string concatenation. If we want to put message 1 and message 2 together, we can use the plus operator, and we can just do this. So I'm gonna copy message 1 or the variable message 1, and now I'm gonna copy the variable message_2, and I use the plus in the middle to concatenate this first message with this second message. So I run, and let's see what happens. So here we can see that the two messages were concatenated, but here there isn't a space between these two messages. So this is the first message and this is the second, and there isn't any blank space in the middle. So what we can do here is to just add a blank space. So I'm gonna copy this one and paste it here and show you how to do it. So here I add a new plus operator, and in the middle we open a string, so with single quotes or double quotes. In this case I'm going to use single quotes here, and to create this blank space I'm going to press space, and here we have our blank space here, and then we run this code, and now let's see, and here as we can see there is a space. So between Python and we have this blank space, and if we want we can assign this new message to a new variable. So I'm gonna assign this to a variable called message, and I write message here, and I include here below the code, and here I can print this. So as you can see, if I run this we can see that the message is there. Okay, now let me show you an alternative way to join two strings. So this is called the F string, and it works like this. You write F and you open a string. So we write single quotes here. So 1 and 2, and here, as you can see, the whole thing is red. So it's like everything is a string. In here, inside, we can write the message. So let's say we write I don't know, a simple hello world. So hello world, and we run this, and as you can see here, this is a string. It just has this F in front of that string. And here, one of the advantages that this F string has is that it can have variables inside the string. So here, for example, we can write a variable opening these curly braces. So these curly braces can have variables inside it. So here I can write message _1, and we can print it. So if we print, we have this string, I'm learning Python. And now if we want to concatenate this first message with our second message, we just have to include curly braces again. I put it here, and now I write message 2, and between message 1 and message 2, I just have to press space, and we have this. So I'm learning Python and it's fun. So here we just press space, and the space also appears here. So for example, if we add some random text, let's say ABC, we get this ABC between Python in between and. So this is how F string works. You just have to write the F, then open single quotes, and inside you can write any message. And to include any variable, you have to open these curly braces, write the variable name, and that's how you join strings. Okay, now it's time to see a data type that is used often in data analysis. I'm talking about lists. In Python, lists are used to store multiple items in a single variable. Lists are order and mutable containers. In Python, we call mutable to objects that can change their values. That is, elements within a list can change their values. To create a list, we have to introduce the element inside the square brackets, separated by commas. So let's create our first list. First, we have to set the name of the list. In this case, I'm going to name it countries. And now to create the list, we have to open square brackets, as I said before. So here we open square brackets, and here we have to write the elements. So I'm gonna include in this countries list just strings, and they're gonna be names of countries. So the first one, I'm gonna write United States. So this is the first element in my list. And to write the second, we have to use the comma. So here, comma, and now the second. So let's write India, 2 more. So now China, and finally Brazil. So these are the 4 countries. As you can see here, this is a list. So we have the square brackets that represent the list, and we have 4 strings. And this is how you define or how you create a list. So now I'm going to run this one, and to see the content, I'm going to paste the name of this list, and now I run. Here I include only strings, but keep in mind that lists can have elements of different types. So for example, one string and the other an integer, and then a float, and so on. And also lists can have duplicated elements. So for example, I can have here United States written twice. So here, for example, I can write United States twice, and that's okay because lists can have duplicated elements. But I don't want it that way, so I'm gonna delete it and leave it as it is. Okay, now if we want to get an element inside this list, we have to use something called indexing. By indexing, we can obtain an element by its position. So each item in a list has an index, which is the position in the list. Python uses zero-based indexing. That is, the first element, so United States, has an index 0. The second, so India, has an index 1, and so on. To access an element by its index, we need to use the square brackets again. So let's see some examples. Let's start by getting the first element, so United States. So what we have to do is to write the name of the list, in this case countries, and then open square brackets. And inside square brackets, we have to write the position of this element. So it starts with 0, so we write 0 to get the first element, and then we run this code, and as you can see, we got the first element. So if we write here countries square brackets 1, we get India. And if we write countries square brackets 2, we get China. And if we do this with the number 3, we get Brazil. So to verify this, I'm gonna print each of them. So let's see what happens. So here, print, and finally print this one. And now I'm gonna run, and we should get each element of the list from United States to Brazil. So let's try out. So here we have each of them, United States, the first one, then India, then China, and then Brazil. So it's correct. So this is the most common way to use indexing, but there is also negative index. This helps us get elements starting on the last position of the list. So instead of using indexes from 0 and above, we use indexes from -1 and below. So let's get the last element of the list, but now using a negative index. So we want to get the last element, which is Brazil, and we did it before with countries square brackets 3, but now we're gonna do it with negative indexing. So here I'm gonna write countries, I copy and paste it here, and now I open square brackets, and instead of writing 3, we're gonna write -1. And this -1 represents the first element starting from the last position. So Brazil will be -1, China is -2, India -3, United States -4, and that's how it works. So I'm gonna run this one, countries square brackets -1, and we should get Brazil, and we got it. So let's do this one more time, and in this case I want to get United States, which is -1, 2, 3, and 4. So it's countries -4. So we run this and we got United States, but now using a negative index. Okay, now let's see something called slicing. Slicing means accessing parts of a list. A slice is a subset of list elements. A slice notation takes the form of list, so the list name, and then square brackets and the start, then this colon and stop. This start represents the index of the first element, and stop represents the element to stop at without including it in the slice. So let's see some examples. So I'm gonna use this countries list again. I'm gonna copy this one and I'm gonna paste it here. So this is the name of my list, and now I open square brackets, and we're gonna get let's say we're gonna start at position number 0, and then colon, and let's get from 0 to the position number 2. So we have to write 3 because it stops at 3 without including this element in the position number 3. So let's run this one, and as you can see here we have index 0, index 1, and index 2. So it didn't include index number 3. And now let's say we want just the first element. So we write from 0 to 1. So it's only 0 and 1 no, because it doesn't include 1 and it stops at 1. So here I run and we got only United States. So now let's try something different. Let's say we want to get elements from index 1 to the last one. So let's say, let me see here, we want to get from India to Brazil. So it's 1, 2, and 3. So we have to write 4 because it stops at 4 and we got 3. So let's write here 1, 2, 4, and we should get, yeah, India, China, and Brazil. So this is one way to do it. But another way to do it is just delete this and leave it as it is, and then run the code. And as we can see, we got the same result. So every time you want to get from one position to the last one, you can omit the stop element and just leave it without that element. So just as we did here. And the same goes for the start. So let's say we want to get from the first position, so index 0 to 2. So we don't include the start element and we write only colon and 2. So we run this and we get United States, and then we get India because this is the first and this is the second. So every time we want to get from the first element or until the last element, we can omit the start and stop elements as we did in these two examples. Okay, now let's see how we can add elements to a list. There are different methods that help us add a new element to a list. So let's have a look. The first one is called append, and we're going to use the countries list as an example. So I'm going to write countries just so you can remember, and here it's countries, and as you can see it has 4 elements. And let's say we want to add a new country to this countries list. So what we can do is just write here or paste here countries, and now add append or that append. And here, as you can see, this is a method. So inside parentheses, we can write the new country we want to add to this list. So let's say we want to add the country Canada. So we write Canada, and now we run this code. As you can see, nothing is printed, but if we print the countries list again, we see here a new element. So as you can see here, the append method adds a new element at the end of the list. So this is by default at the end. But what happens if you want to add an element in a different position? So here you can use another method, which is called the insert method. So let me show you here. I'm gonna copy countries, and now I'm gonna use the insert method. So I write that insert, then parentheses, and this one accepts 2 arguments. The first one is the index, so the position of the element you want to insert. So let's say we want this at the first position, and the second argument that it takes is the new element you want to add. So in this case, let's say we want to add the element Spain. So this is another country, and it's gonna be in the first position, so index 0. So let's try. I run this one, and again nothing happens. Apparently nothing happens. And here if I run this countries list again, we can see that there is a new element, and this element is Spain, and it's located in the first position, unlike Canada that was placed in the last position. This is one of the difference between the append method and the insert method. So with insert, we can specify the position we want to insert this new element, but with append, the element is added at the last position. Another thing you can do is to join 2 lists using the plus operator. We use the plus operator to concatenate strings before, but you can also join 2 lists. So let me show you here. I'm gonna create a new list just to show you how it works. So my new list is gonna be called countries underscore 2. So I'm gonna include different countries. So in this case, it's gonna be the UK, then Germany, and let's write Austria. So we have 3 countries in this new list. And now I'm going to run this one. And if we want to concatenate this first list, countries, with this second list, countries too, we can use the plus operator. So here I write plus, and then I run this one. And as you can see, I got the 5 elements from the first list and the 3 elements from the second list. And another cool thing you can do in Python is putting these 2 lists inside another list, which is called nested list. So let's try out. So here I'm gonna create a new list, and it's gonna be called nested underscore list. And here I'm gonna open square brackets to create a new list. And as elements, I'm gonna write countries, which is my first list, and then comma, and then countries underscore 2. And this is my second list. So as you can see here, these elements inside this list, the first is a list and the second is a list. So we have lists inside another list, which is called a nested list. So I run this one, and then I paste nested underscore list, and we run, and we get here the first list as first element and the second list as second element. You won't see this nested list so often, but you will encounter this a couple of times, so it's good for you to know. So now we're gonna see the opposite of adding an element to a list, which is removing an element. So here I just pasted the countries list we had before, and what we're gonna do is to remove some of the elements of this list. So there are different methods that help us remove an element from a list. One of them is the remove method. So to remove an element using this, we have to first write the name of the list, and then use the that sign, and then write remove, and write parentheses, and inside here we have to write the element we want to get rid of. So first it's United States, so I write United States, and let's run this one. And as you can see, apparently nothing happens, but if we paste countries, here we have all the elements, but United States is not there. So as you can see, the first matching value was removed. But you can also remove an element by its index. So this is accomplished with the pop method. So I'm going to copy all of this, and now I'm gonna paste it here. So instead of writing that remove, I'm gonna write that pop. And here I'm not gonna use the name of the element, but its index. So I write the index. In this case, let's remove the last one. So it's gonna be index -1. And what pop is gonna do is to remove the element with index -1, and then returns this element. So this element is Canada. I didn't run this code here, so you can ignore it. So I'm gonna comment this one, and our reference is gonna be this list. And to verify, we just write countries and then run. And here, as you can see, there isn't Canada anymore. And that's how you remove an element using the pop method. But there's still another way to remove an item using a specific index, and it's the del. So I'm gonna show you here del. It's the function, del function, and here we have to write the countries list, and then again open square brackets, and here write the index. So I write here the index, and unlike the pop method, we're not gonna get the name of the element we're getting rid of, but just deleting the element. So I run this one, and here we didn't get anything, and I'm gonna print this. So countries, and the element at index 0 was removed, so Spain. because that's the first element. So we delete it, or we remove the first element. So we only got India, China, and Brazil. And there you have it, 3 different ways to remove an element from a list. Okay, now let's see how to sort a list. We can easily sort a list using the sort method. Let's create a new list called numbers and then sort it from the smallest to the largest number. So here first I write numbers and then open square brackets. So I'm gonna write some random numbers. So first 4, then 3, then 10, then 7, 1, and then 2. So this is my list. So I run this code, and now to sort it from the smallest to the largest number, we write numbers, then sort, then open parentheses, and by default this is gonna be sorted from the smallest to the largest number. So I run numbers again, and here it starts with 1 and it ends with 10. And as you can see, it's from the smallest to the largest number. So that's the default behavior of the sort method, but we can control how this works. So we can add the reverse argument to the sort method to control the order. So if we want it to be descendant, we set reverse to true. So here again, I'm gonna create again the numbers list and then write numbers that sort, and inside parentheses I write the reverse argument, and I'm gonna set it to true here, and then I'm gonna print numbers. So here I got an error because here I wrote number and it's numbers. So here I'm gonna add the S and here S too. So run again, and here we have and here we see that the list is sorted from the largest number to the smallest number. So as you can see, the default behavior of this sort method is reverse equal to false. So you can control it here by writing reverse equal to true, as we did here. Okay, now let's see how we can update values in a list. To update a value on a list, we use indexing to locate the element we want to update, and then we set it to a new value using the equal sign. So let's say we want to update the first element of this numbers list. So now it's 4, but we want it to be, let's say 1000. So we write here numbers, and we use indexing. So we write numbers, the first element has index 0. So we write numbers, square brackets, then 0. Then we set it equal to the new value we want to include. So in this case, I'm going to write 1000. And now I'm going to print the numbers list to see the results. So run this one. And as you can see here, the numbers list we got is from the last change we made. So the one that starts with 10. So it's not this one, but this one, because it's the last one we ran. So instead of 10, we replace this one with 1000 because this is the first element with index 0. So we did numbers, square bracket 0, and we update that first element with 1000. Okay, finally, we can make copies of the lists we created. So there are different options to create a copy of a list. One of them is the slicing technique. So as you might remember, to do slicing, we have first to write the name of the list, which in this case is countries, and then we open square brackets. Then we're supposed to write the start and the stop. So in this case, we're not going to write start and stop, but only colon. So if we don't write start and we don't write stop, it means we want the whole list. So let's try this out. I'm gonna run this one, and as you can see here, we got the whole list. So the countries list doesn't have the original values because of the changes we made when we added and remove elements. So I'm gonna paste the original countries list with the 4 original values that are United States, India, China, and Brazil. And here, let's see the changes. And now we test it out, and as you can see, we got the whole list. So from the first element, United States, to the last element, Brazil, because we're slicing the whole list. So if we write here new underscore list, and we set this equal to countries with this slicing, what it's going to happen is this new list is going to have the same values as the country list. So I write here new list, and as you can see here, it has the same values. So we created a copy of the countries list. So this is one way how you can create a copy. And the second way is more straightforward, or is more explicit. So it's using the copy method. So we write again countries, the name of the list, and then we use the copy method. So we write copy and then parentheses. So with this, we create a copy of this list. So let's run this code, and as you can see here, it returns the list. But if we assign this to a new list, we're gonna create a copy. So here I'm gonna write new underscore list underscore 2. So here we assign this copy to this new list. So I'm gonna copy this new list and paste it here. And as you can see here, we have the values of this list, which are the same as the original countries list that is here. And that's it. That's how you make a copy of a list. So now let's see how dictionaries work in Python. In Python, a dictionary is an unordered collection of items used to store data values. And a dictionary contains a key and a value. So this is what you will often see in a dictionary. So here, for example, the name of my dictionary is my_dict. And to create this dictionary, we have to use these curly braces. So we open curly braces, and inside we write our first item. And the first item consists of a key here on the left, and then a value here. And it's separated with the colon. So here we have the key, then colon, and then the value. And then we have here the second item. So the second key and the second value. So now let's create a dictionary that has some basic information about me. So I'm gonna name this dictionary my_data. And now to create this dictionary, I'm gonna open curly braces. And the first key is gonna be name. So I write name, and it has a value that is my name. So I'm gonna write Frank. So I open single quotes and then write Frank. And then I'm gonna add a new item. So I write comma, and then the second key is gonna be age, and the second value is gonna be my age. So in this case, I'm gonna write my age, which is 26. So as you can see here, the first is a string, the first value is a string, and the second is a integer. So we can mix different data types. So now I press Control Enter to run this code, and we created this dictionary. So now I write my_data, and here you have the dictionary we created. So here we can get the keys of this dictionary. We only have to write my_data dot keys. So this is the keys method. So we run this, and we get this dict_keys, and the values are name and age, which are the keys of this dictionary we created. So name, the first key, and age, the second key. Now we can get also the values. So my name and my age. So we just have to use the values method. So I'm gonna paste this one here, and instead of writing that keys, I'm gonna write that values. And now run this, and we get my name and then my age. So next, I'm gonna get the items. So as I said before, an item is this. So this is the first item, and this is the second item. So we can say that the item is a pair of key and value. So we can get this by using the items method. So instead of writing that values, I'm gonna write here that items. and then run this one. So here we got the first item, so the first pair key and value, which is my name and, well, the key name and then my name Frank, and then the second item, so the key name age and the age, which is 26. Now we can add a new pair of key value in this dictionary we created. So let's say we want to add my height, so I write my data, and let's say we want to add the key name height, so I write height, so we use square brackets here, and then we set this to the value. So let's say it's 1.7, so I write my data and then square brackets, then height inside it, and then equal to 1.7. So if I run this and then I run the dictionary, we can see that there is a new item and it's the height. So height colon and then 1.7. This is how you add a new item to the dictionary. And now we can update this height. So let's say I'm not 1.7, but I'm 1.8 meters. So what we can do is to use the update method to update this value. So I write my underscore data, and here I can use the update method. So I write update, and then inside parentheses we have to open curly braces to update this new item. So I'm gonna write the key, which is height, and then I'm gonna set the new height, which is 1.8. So let's try this out. I run this and then let's see the values. So let's see if it was updated. So I run this and we got the height 1.8. So it's perfect. So now let's see how we can make a copy of a dictionary, the same way we did before for the lists. So to make a copy, we just have to write the name of the dictionary. In this case, it's my underscore data. And then just as we did for the list, we can use the copy method. So we write that copy with parentheses, and then we create a new copy. So here you can see the copy, and now I can assign this to a new dictionary. So I'm gonna write new underscore dict, and now I'm gonna copy this one, I'm gonna run, and then I write new underscore dict and run this, and as you can see, it has the value of the my underscore data dictionary. And something I didn't tell you when I make a copy of the list is that if you change the data inside the my underscore data dictionary, so the old dictionary, the effect is not gonna be seen in the new dictionary. So for example, if we write 1.9 and here I update this in the old dictionary, so here you can see height 1.9. And if we run this new underscore dict, we can see that after running, this height remains with the same value, 1.8, and it doesn't change to 1.9. This doesn't happen if you make one of these copies. Most people do. So let me show you what I'm talking about. So most people just make a copy doing new dict underscore 2 equal to my data. So this is the old dictionary and this is my new dictionary. So what happens if I run this and then I'm gonna show you the values of this new dictionary. So this is 1.9, and if I update this to, let's say, 1.95, so update here, here is 1.95, and if I run this new underscore dict underscore 2, we can see that the value was updated too, and this shouldn't happen. So if you want to create a new dictionary that works independently from the old dictionary, you should use the copy method, and this is the same if you're making a copy of a list. Finally, let's see how to remove elements from a dictionary. So just like we did with the lists, we can remove an item in a dictionary. So there are different options. First, we have the pop method. So we write my underscore data. I'm using the old dictionary we've been using so far. So my underscore data, and I'm gonna write that pop. So this is the pop method. So here I can write the key. So in this case, I'm gonna write the key. Let me see here, my underscore data, the key name. So I write pop, then parentheses, then name. So as you might remember, the pop method returns this value of the key. Before we did with the list, and it returned the list element. In this case, it returns the value of the key. So this is the key name, and it returns the value. So if we print this my underscore data dictionary, we see that this pair key value isn't here. So we successfully removed this item. Another way to remove an element or an item from a dictionary is using the del function. So we write del, and then we write the name of the dictionary. So my underscore data. And then we have to specify again the name of the key. So we open square brackets and open quotes. And here, let's say we want to delete or remove the H key with its value. So we write H, and we run this, and then if we print this dictionary again, we get the dictionary, and we see that the H key was removed, and also its value. And finally, you can remove all the items in a dictionary with the clear method. So we write my underscore data and use that clear with parentheses. And now if we print this dictionary, you can see that this is an empty dictionary because we remove all the elements from this dictionary. Now let's see one of the most common statements used in Python. This is the if statement. The if statement is a conditional statement used to decide whether a certain statement or block of statements will be executed or not. Here you can see the syntax of this if statement, and as you can see, it starts with the if keyword followed by the condition. So if the condition is true, this code here is gonna be executed. And if the condition is not true, so it's false, the code here in the elif, it's gonna be tested. So here in this elif block, this new condition will be tested. And if this is true, this code below will be executed. But if it's not true, then the else block will be tested. And here, this is the last block, and automatically this code will be executed. So here one little detail that most beginners forget to write is the colon. So it's sometimes easy to forget it's there, but you have to include it. And one other things some people miss is this indentation. So here there is an indentation you have to include after the colon. So every time you write here colon, you press enter, and you automatically, in most text editors, you're gonna get this indentation. But if for some reason you don't get that indentation and you get something like this, you can indent this line by using the tab key in your keyboard. So just press tab and it's gonna indent this line. So make sure you write the colon and you include an indentation for each code that will be executed. So here, here, and here. So now let's have a look at some examples to see much better how the if statement works. So first I'm gonna create a new variable, and as you might remember, to create a variable you have to write a name of this variable. In this case I'm gonna name it H, and then you have to set it a value. So in this case this is gonna be a number, so I'm gonna set this H to the number 18. And now I'm gonna write this if condition or if statement. So I write if H is greater than or equal to 18, then colon, and then this code is going to be executed. So if this is true, I'm going to write print and then a message. So if this person, or if the age is equal or greater than 18, I'm going to write the message, you're an adult. And as you can see here, I'm using single quotes and I wrote the apostrophe. So I'm going to use double quotes and everything is fine now. So here print, then the message, you're an adult. So if this isn't true, I write else and then colon and print here a new message, which is you are a kid. So let's see this again. So if the age is equal or greater than 18, then we print you're an adult. But if it's less than 18, we print you're a kid. So here we run this code and we should get this because 18 is equal to 18. So let's run, and as you can see, we got the message you are an adult. So now we can play with this. We can change the age value. So here I'm going to set it to 15. So I run, and as you can see here, 15 is less than 18. So this is false and this code is executed. So this block here, it's going to be executed. So we got you are a kid. So we can try this one more time. So in this case, I'm going to write another age, so 30. And again, 30 is greater than 18. So this is executed. So you're an adult. So now let's add a new block. And I'm going to use the elif. So I write elif and then age and then greater than, let's say 13. And then colon, press enter, and we got this indentation. And then we print another message. So if the age is equal to or greater than 13, we write the message, you are a teenager. So teenager. So if it's between 13 and 17, or well, less than 18, it's gonna be you're a teenager. But if it's less than 13, it's gonna be you're a kid. So let's try this out. So I write first 10 and then we get you're a kid because it's less than 13. Then we'll change this to 14. And then we get you're a teenager because 14 is greater than 13. And finally we write 20 and we get you're an adult because 20 is greater than 18. And that's it. That's how the if statement works. Now it's time to see one of the most common loops in Python. This is the for loop. Python for loops are used to loop through an iterable object and performs the same action for each entry. One example of an iterable object is a list. So we can loop through each element of a list and perform the same action on each element of that list. Here you can see the syntax of the for loop, and as you can see, here is the for keyword, and then we have to use a variable. Then we have to write the in keyword and then the iterable. In this case, as I told you before, the most common is the list. So you have for variable in list. I'm gonna write here list so you can see much better. And then we have to write the colon. And then after a colon, it goes an indentation. So here we have the indentation and the code that will be executed for each iteration here that we make with the for loop. So to see this much better, I'm going to use the countries list we created before. So this is the countries list, and I'm going to loop through this list. So I write for, and then we have to set a variable that is going to be just temporarily. So this variable is gonna be called country. So this variable doesn't exist, we just create it temporarily. So for country in, and then we have to write the name of the iterable, which is in this case a list, so countries. So for country in countries, and then colon, and then enter, and we get this indentation. Then we say print country. So for this variable in this iterable, which is a list, print each element. This is what we're saying in this for loop. So we run this, and as you can see, each element of the list country is printed. So we're looping through the countries list and printing each element. So the first is United States, then India, then China, and Brazil. And this is how the for loop works. Now let me show you a new function that you can implement along with the for loop, and it's called enumerate. So I'm gonna write here enumerate, and here I'm gonna put this countries list inside this new function. So what this enumerate function does is to enumerate each element of the countries list as we loop through the list. So I'm gonna add here a new variable, and it's gonna be I, then comma, and then country. So this enumerate will return two elements. The first one is gonna be the number of the loop, and the second one is gonna be the element itself. So here I have to print apart from the country, the I variable that I just created here, or it's just temporarily here. So I write print I, and then print country. So here we're gonna print here the number of the iteration and the element. So I run Control Enter, and here we got it. So first is United States, in the iteration, the first iteration which is 0. Then we got India in the second iteration, which has 1, and so on. So as you can see here, the I starts with the 0. So this is how enumerate works. It starts with the number 0, and it returns the number of the loop and the element. And finally, let's loop through elements in a dictionary. So let's use the dictionary we created before, that was my_data. Well, this is empty, so I'm gonna use the original dictionary. So here I have the original dictionary, and it's here, so I'm just going to print it. So this is the dictionary, and now we're gonna loop through this dictionary. So let me show you here. First, we have to write for, and then we write key and value, because one item, as you might remember, is made of a key and the value. So key and value. So we say for key, comma, value in, and then the name of the dictionary. So we write my_data. And now to get the items of this dictionary, we have to use the items method. So we write that items and then parentheses. Then we write colon, and we press enter. So here we can print the key, and we can also print the value. So key and value. And then we run this code, and as you can see here, we get the key, the first key, and we get the value. We get name, and we get Frank. And then the second key, age, and the age 26. So this is how you loop through elements or items inside a dictionary. Okay, now let's see how functions work in Python. A function is a block of code which only runs when it is called. You can pass data known as parameters into a function. So here it's the syntax of a function, and as you can see here, we have first to set the keyword def to create this function, and then we have to write the name of this function. And inside parentheses, we define the parameters of the function that we're creating. Then we write colon, and below you have to write the code. and every function should return something. So we have to use the return keyword and then return something like a variable, for example. So now let's create a basic function. So first we write def, and then we write the name of the function. So this function is going to do something really simple. It's going to sum the values we pass into it. So it's going to be named sum underscore values. And as parameters, we set a, comma, b. Then colon and press enter. Then what this function is going to do is to add the a plus b values, and we're gonna set this equal to x. So we write x equal to a plus b, and as I told you before, you should return something after we finish the function. So we write return, and here we're gonna return the x variable. So we write x, and that's it. That's how you create a function. I ran this code, and as you can see, apparently nothing happens, but this function was created. So to use this function, we have to call it. So to call this function, we have to write the name of the function, and then we pass some parameters in. In this case, it's called arguments when you call the function. So I'm gonna write the argument 1 and argument 3. So once you call this function, it's gonna go to the function here and is gonna set this 1 equal to a and this 3 equal to b. So you have 1 plus 3 and this is 4. So x is gonna be equal to 4, and then this function is gonna return the value of x, which is 4. So this is supposed to return the value of 4. So we run this and we got the value of 4. So this function is working properly. Okay, now let's see some built-in functions that Python has. Python has lots of built-in functions that can help us perform a specific task. Let's have a look at some of them. So let's start with the len function. We only have to write the word len, and then we open parentheses. And as you can see here, Jupyter Notebook gives the green color to functions. And now let's calculate the length of the countries list. So I have here the countries list, and now I'm going to copy this one, paste it inside parentheses, and what the len function is going to do is to calculate the length of any iterable object. In this case, the countries list is an iterable object, and now I'm going to run to calculate the length of this object. So I run this one, and as you can see here, the length is 4, and this is how the len function works. Now let's see a different function, and in this case I'm going to create a new list that contains only numbers. So I'm going to write random numbers here, 10, 63, 81, then 1, then 99. So this is my new list, and I created this list with only numbers to try the max and min function. So the max function is this one. We write max and then parentheses, and this one returns the item with the highest value in an iterable. So my iterable is this list, and we're gonna get the highest value of the elements inside this list. So we run this one, and as you can see here, the maximum value is 99. And we can do also the min function, and it's gonna have the opposite effect. In this case, we're gonna get the minimum value of this list. So we run and we get 1. Okay, another common function used in Python is the type function, and this function gives us the type of the object. We only have to write type, and what this function does is to return the type of an object. So in this case, let's copy and paste the countries object, and if we run this, we can see that this object is a list, and that's correct because here we created a list with square brackets. So that's what the type function does. And finally, the last function we're going to see is the range function. This one returns a sequence of numbers that start with a number and ends with another number. So let's see how it works here. So this one has 3 arguments. First, the start number. This one, I'm going to write 1. Then the number where the sequence stops. In this case, I'm going to write, let's say 10. And then the last argument is the increment. So how this sequence is going to grow, by how much. So in this case, I'm going to say that this sequence is going to grow by 2. So I write 2. Now I run. And as you can see, nothing happens. We only get the same text here. But if we make a loop here, so I write for I in range, now print this I. So this is a for loop. We saw this before. And here we run. And as you can see here, we're iterating over this range. And we're getting the elements inside this range. So the first element is 1. The second is incremented by 2. So 1 plus 2 is 3. Then 3 plus 2, 5. Then 7. And then 9. And then we should get 11. But the last element here, it's 10. So this sequence stops at 10. So we only get until number 9. And that's how the range function works in Python. And that's it. Now you know the most common built-in functions in Python. Okay, in this video, we're going to see what are modules in Python. In Python, modules are files that contain Python code. A module can have classes, functions, and variables, and even runnable code. And to get access to a module, we have to use the import keyword, this one. And to see a module in action, we're going to see the OS module. And this one comes with Python, so you don't need to install it. So to get access to this OS module, we have to write import OS. And that's it. We only write this. And now let's see some functionalities of this module. So the first one that we're going to see is the get current directory method. So to get access to that method, we write OS, then get cwd, and then parentheses. So this cwd stands for current working directory. So we're going to get the directory where our Jupyter Notebook file is located. So this file I'm working with right now. So let's run and let's see what happens. So as you can see here, I have the path where the Jupyter Notebook is located. So this is the complete path. And you can see it by using the getCwd method. So now let's see another method. And in this case, we're going to list all the elements in the folder where this Jupyter Notebook file is located. So here, to do that, we're going to use the method listdir. So this means list directory. And I'm going to run it. And as you can see here, I have this Jupyter Notebook file that is named untitled. As you can see here, the name of my file is untitled. And these other elements, you can ignore it. They are not files. They are just some hidden elements in my folder, but they don't matter. So right now, the only file I have in this folder is this untitled file. So this is what the listdir does. So it lists all the elements in the folder where this Jupyter Notebook file is located. And now let's see the last method, which helps us create a new folder. So this method is called makeDirs, and we have to write os that makeDirs, and then parentheses. And inside parentheses, we have to write the name of the folder we want to create. So in this case, I'm going to name it new folder, simple as that. And now if we run, we're going to see that nothing happens. But now if we use this listdir method to list all the elements in my folder, we can see that there is a new folder. So here, if we compare this result we got before with this new result, we can see that there is one new element. And this element is the new folder element. which is the folder we created using the make_dir method. And that's it. Those are some basic things you can do with the OS module. In the following videos, we're gonna install different libraries, packages, and modules so we can do even more things in Python. In this first introduction to Pandas, we're gonna learn what is Pandas. We're gonna compare Pandas with Excel, and then we're gonna learn what are Pandas data frames. So first, Pandas is probably the best tool to do real-world data analysis in Python. It allows us to clean data, wrangle data, make visualizations, and more. You can think of Pandas as a supercharged Microsoft Excel, because most of the tasks you can do in Excel, you can also do it in Pandas, and vice versa. That said, there are many areas where Pandas outperforms Excel. So before you learn Pandas, let me show you why you should learn Pandas, especially if you already know Excel. So there are some benefits that Pandas has over Excel, or Python has over Excel. So before dedicating time to learning Pandas and also Python, let's see what are these benefits. So first, limitation by size. Excel can handle around 1 million rows, while Python can handle millions and millions of rows. Another benefit that Python and Pandas have over Excel is the complex data transformation. So in Excel, memory-intensive computations can crash a workbook, while in Python, when you work with Pandas, you can handle complex computations without any major problem. Also, Python is good for automation. While Excel was not designed to automate tasks, you can create a macro or use VBA to simplify some tasks, but that's the limit. However, Python can go beyond that with its hundreds of free libraries available. And finally, Python has cross-platform capabilities. This means that Python code remains the same regardless of the operating system or language set on your computer. Okay, before I start writing code, let me explain to you the core concepts of Pandas. So we're going to start seeing the concepts of arrays. So arrays in Python are a data structure like lists. So you can find like one-dimensional array or two-dimensional array, also known as 2D array. And the two main data structures in Pandas are series and data frames. So the first is a one-dimensional array, while the second, a data frame, is a two-dimensional array. In Pandas, we mainly work with data frames. But if you didn't understand so much the definition of a data frame with arrays, let me show you another definition. This one using Excel. So a Pandas data frame is the equivalent of an Excel spreadsheet. Pandas data frames, just like Excel spreadsheet, have two dimensions or axes. So there are two axes, and one is the row and the other is the column. So the column is also known as series. So what we've seen before, this one-dimensional array series is a column. This is another name to call the columns in a Pandas data frame. On top of the data frame, you will see the name of the columns, and on the left side there is the index. By default, index in Pandas start with 0. The intersection of a row with a column is called a data value, or simply data. We can store different types of data such as integers, strings, boolean, and so on. Right now you see on the screen a data frame that shows the US states ranked by population. I'm going to show you the code to create a data frame like this later, but now let's analyze this data frame. So the column names are also known as features. So our features here are states, population, and postal, while each row value is known as observation. We can say that there are 3 features and 4 observations because there are 3 columns and 4 rows. Keep in mind that a single column should have the same type of data. In our example, the states and postal columns only contains strings, while the population column only contains integers. We might get errors when trying to insert different data types into a column, so avoid mixing different type of data. So now let's see the terminology translation between Excel and Pandas. So as I mentioned before, in Excel we work with worksheets, and in Pandas we work with data frames. So the columns in Excel are also known as series in Pandas, but we also mention, or we also say often, the word columns. And in Pandas we worked with index. So the index are those numbers that are on the left. And in Pandas we also say rows. We have many rows, well, observations too, but rows are fine. And finally, in Pandas we work often with this NaN that stands for not a number, and this is the equivalent of an empty cell that you might find in Excel. So that's it for now. In the next video, we're going to learn how to create a Pandas data frame from scratch. Welcome back. In this video, we're going to learn different ways to create a Pandas data frame. So as you might remember, a data frame looks like this. It has columns and rows, and the columns are series. So a series are a 1D array, and arrays is how we create a data frame. So this is the first way to create a data frame, with arrays. So these are arrays. We have 1D arrays, 2D arrays, and 1D arrays are basically columns, while 2D arrays are data frames. So usually to use arrays, we use a library named NumPy. And NumPy is what is under the hood of Pandas. So to use NumPy, we have first to import NumPy. We're going to do that a bit later when we write code. But just to give you an idea of what a NumPy array looks like, here I wrote a basic array. We have to use np.array to create this data frame that you see on the right. And well, this is one way to do it. You can also use lists, as I'm showing you right now. And as you can see here in the second option, when you create a data frame with lists, you don't need to use NumPy arrays because you're using some kind of list arrays. So we're going to write the code to create a data frame with arrays, but let's see the second option to create a data frame. So the second option is dictionaries. You can create a data frame with dictionaries. And as you might remember, a dictionary has a key and a value. So we can use the key as column name and the value as the data. So the value can be a list. So this data will be many elements inside a list. So a pair of key and value is known as item in a dictionary, and in this case it's going to be a series because it's one column, what we have here. So this is the second way to create a data frame with dictionaries, and we're going to see that with code a little bit later. But now let's see the third way, which is with CSV files. So CSV files are files that can be opened in spreadsheets like Excel. And this is the easiest way to create a data frame because we only need to read the CSV file and then the data frame is created, and that's it. So now let's go to Jupyter Notebook to create a data frame, writing some code. Okay, now we are on Jupyter Notebook, and here we're going to write the code to create a data frame, and we're going to use the 3 ways I showed you before. So the first thing we're gonna do is to import the libraries we're gonna use to create a data frame. So that's the first line of code, and I already wrote that. So it's here. So first we import pandas, and then we import numpy. So import pandas as PD. PD is just a convention to name pandas, and NP is a way to name numpy. So to run this code, just press Control Enter, and now just wait, and we imported pandas and numpy. So let's see the first way to create a data frame. So the first is with arrays, and to create an array, we have to use a numpy. This is the first option. So we write np, which is the short name for numpy, and then we use the array method. So we write array, open parentheses, and inside we write the array we want to create. So I'm gonna write random numbers just for the sake of this example. So I open double square brackets, and then let's say 1 and 4, and then let's say 2 and 5, and the last one is gonna be 3 and 6. So each pair of let's call it list, actually they are lists, each list represent a row. So this is the first row, or this is going to be the first row, this is going to be the second row in our data frame, and this is going to be the third row. So here we can name this array, and I'm going to name it as data. So data is equal to this numpy array. So I'm going to execute this code, and now we have this data. So we created the array using numpy. Now let's create a data frame with pandas. So to create a data frame with pandas, we have to write pandas. In this case, I can write PD because I name it like this here in my first line of code. So I write PD, and then to create a data frame, we use the data frame method. So we write data frame, and then we open parentheses, and here we have to fill some arguments. So the first one, and that's something that you always have to include in this data frame method, is the data, because you cannot create a data frame without data. So first we include the data. So first copy here our array, and then you paste it here. That's the first argument. So you can create this data frame as it is. I'm going to show you here. Just Control and Enter. So as you can see here, here's my data frame. But as you can see, it's full of numbers, and the column names also have numbers, and the row names also have numbers. So to make it more understandable, we can rename these column names and row names, or index. Actually, the name of the row names are index. So first we can name this index as rows. For example, you only need to add the index argument, as I'm writing right now, and then you have to specify the names you want to set. So you have to open a list. So this this second argument has a form of a list. So the first element is going to be the first index. So here, 0. So in case you don't want it to be 0, you can set here another name. So in my case, I'm going to set it as row 1, then comma to set the second index as row 2, and the third as row 3. So now we can add we can modify also the column names. We have to use the column argument, and here we write it, columns, and then we open square brackets because it's a list here that we're gonna edit, and in this case we have to modify only 2 elements. So the first is gonna be, I want to name it col1, and the second col2. So I'm gonna write this one, and actually I'm gonna name this data frame So I'm gonna set it to a variable, and this is gonna be equal to df. df is the common way to name a data frame. So df stands for data frame. So I'm gonna run this code now, and as you can see here, it ran. And now to show the data frame, I can write here df. So df, and now we have here the data frame. And as you can see here, the first row 1 4, it's my first list, and the second is the second row, and the first column, well, that's a series as we discussed before. So we have also the column names that we modified and the row names. So now let's quickly see how to create a data frame with arrays, but in this case without NumPy. So I'm gonna copy this line of code and I'm gonna paste it here, option 2. So here I'm gonna paste this because this is the base of this arrays with list shape, and I'm gonna just delete this. So I don't want NumPy array anymore, just this double square brackets. So I run this. Now to create the data frame is the same way we did before, so just copy this and paste it here. So run this, and now I can write df, and now execute this code. So as you can see, we have the same result. I'm just showing you the second way so you don't have to worry about learning right now NumPy. Okay, now let's create a data frame from a dictionary, and we're gonna use lists in this example, and we're gonna create a data frame using more meaningful data. So in this case, to create a dictionary, I'm gonna use 2 lists. The first is gonna be a list named states, and the second it's gonna be the population, and it will contain the population of each state. So the first list is states, and I'm gonna write it here, and I open square brackets because this is a list, and now I write some states in the US. So the first is California, the second is gonna be Texas, let me write it here. The third is gonna be Florida, and the last one, New York. So I quickly write it here, and now I'm gonna create a population list. So in this case, I'm going to paste this data. So I pasted the population on each state, and now I'm gonna create a dictionary from these 2 lists. So I'm gonna write the name of the dictionary. So the name is gonna be dict_states. Then this is a dictionary, so I should use curly braces. And now I'm gonna set the name of the key. So the first key is states, then colon, and now the element or the value. So this is states, the first value, and the second key and value is population. I'm just gonna set it to with capital letter, and the second is the list population that we have here. So with this we create our dictionary. So I'm gonna run these 2, and now we have lists and the dictionary. So now we can easily create a data frame using the data frame method that we used before for the first option when we create a data frame with an array. So to do it, just write pd, then data frame, and now we have to write inside parentheses the name of the dictionary. So I'm gonna copy dict_states, and I'm gonna set this to a new variable. So I'm gonna name this df_population. So data frame about population. So now I run this, and here I got an error because I didn't write data frame correctly. Here is in capital letter, so I run again, and now everything is okay. So now to show the data frame, I just paste this one here, and now I run. So here we have this data frame, and as you can see here, my first key, states, is the name of my first column, and the data inside the states list is here. So here is my first column or my first series. And the same goes for population with its data. So here we created a data frame using a dictionary. Okay, finally, let's create a data frame from a CSV file. To create a data frame from a CSV file, we have to use the read_CSV method. So first we write as usual PD, that stands for pandas, and then we use the method. So we write read_CSV, open parentheses, and then we have to write the name of this CSV file. Here I'm gonna paste the name, so it's name students performance.csv. And to download this data, you can check the notes of this video. And actually we can have a look at this data before importing into Pandas. So it's here, I have it in Google Sheets. And as you can see here, we have the scores of some exams, math, reading, and writing. And we have some other data. So we can import all of this data, all of the 1000 rows in Pandas. So all of this is gonna be here. So here we only have to define the name of this data frame. So here I'm gonna name it df_exams. So now I run, and to show now the first 5 rows of this data frame, we can use a method named head that we're gonna see later. But just to give you an idea of this, we can write that head and we get the first 5 rows. So as you can see here, we have the first 5 rows of this Excel or actually CSV file. And as you can see here, for example, the first row, it says female group B and math score 72. So let's check if that data is the same here. So we have female group B and math score 72. So we have all this data here in this data frame. So if we want to see all of them, all of the rows here, we can forget about the dot head, and now we have all the rows. Well, here we cannot see part of the rows. I'm going to show you how to see that part later in this course. But now, as you can see, if we run this df_exams, we can see like the summary of this data set, or well, data frame in this case. By the way, in Pandas, or when we work actually in Python, we usually call this type of CSV files, we call it data sets. And when we read a data set using well, Pandas, the result is a data frame, what we have here. So the CSV file is a data set, and this when we read it with Pandas is a data frame. And that's it. These are the 3 ways to create a Pandas data frame. Okay, now it's time to see how to display a data frame in Pandas. So here I have the CSV file we used before to create a data frame. And a little detail I forgot to mention before is that this CSV file should be located in the same directory where your Jupyter Notebook script is located. So what I mean by the Jupyter Notebook script is what we're seeing right now. I mean, what we're working right now is a Jupyter Notebook script, this file that we're working right now. So what you have to do is to download this CSV file and place it in the same folder where your Python or your Jupyter Notebook script is located, in the same folder. And this is how you're gonna read this CSV file using the read_CSV method. So just make sure both the CSV file and the Jupyter Notebook script is in the same place, in the same folder. Okay, now I'm gonna run these first 2 lines of codes that we've seen before. So the first import pandas and the second reads this CSV file. So I run this, and now we have this CSV file stored into this df_exams. This is my data frame. So now let's see how we can see this data frame. So the easiest way to see this data frame is just copying this name, this variable, and now pasting it here. Now I execute this, and now we have the data frame. Actually, this is a summary of the data frame because not all the rows are seen here. So here, if we scroll down a little bit, we can see here that there are 1000 rows and 8 columns. So here we can see all these rows and the columns, but as you can see here in the middle, we cannot see the rows. So it's until 4 and then it continues with 995. So usually when we work with pandas, we don't need to see the data one by one, so row by row. That's not how we do it with pandas. But if for some reason you need to see all the data in pandas, as you will do it here in Excel or in Google Sheets, I'm going to show you a way to do it a bit later. But first, I'm going to show you different ways how we usually display a data frame in pandas. So the first way to do it is using the head method. So here, to use the head method, we only have to write the name of the data frame, in this case df_exams, and then write head, then parentheses, then we run this, and this is how we get the first 5 rows in a data frame. So as you can see here, we have from row 0 to row 4, and this is how we got these first 5 rows. So this is the head method. In the same way, we can get the last 5 rows of this data frame by using the tails method. So here we only have to write again the name of the data frame, in this case, well, the same df_exams, and then write that tails, then parentheses, run this, and actually I think it's tail. Yeah, it's tail in singular, and now we get this, we got the last 5 rows. So it's from 995 to 999. So these are the 5 rows, the last 5 rows. And now in case you want to get more rows, so not only the first 5 or the last 5 rows, you can add an argument to the either the head or the tails method. So I'm going to use here the head method as an example. So here I copied this, and now I'm going to paste it here. So let's say now we want to get the first 10 rows. So we write here inside parentheses 10, and now we run this. And I scroll down here, and we can see that the first 10 rows are here. And we can do the same with tail. So here I write tail, and as we can see, the last 10 rows are displayed here. So you can specify the number of rows that you want to display, and that's how you do it. So now I'm going to show you how to display all the rows of this data frame as you will do it in Excel or in Google Sheets. To do so, first we have to know how many columns this data frame has. So an easy way to get the number of columns is using the shape attribute. To get the shape attribute, first we write the name of the data frame. So in this case, df_exams. And then to get to this attribute, to get access to this attribute, we use the dat. And then the name of the attribute, in this case, shape. So now we run this, and we get 1008. The first is the number of rows, and the second is the number of columns. So we have 1000 rows. So now to display all the rows, we have to use the set_option method. So we write pd.set_option. And inside parentheses, our first argument is going to be the following: display.max_rows. So here we have to specify one more argument, and this is going to be the number of rows we want it to have. So here it's 1000 because we have 1000 rows, and we run this, and as you can see here, nothing happened because we only modified the default behavior of pandas. So if we want to get the data frame, we just press enter and execute this data frame. I'm going to scroll down, and here, as you can see here, there are all the rows of this data frame. So I'm going to scroll all the way down here, and as you can see, it says 999. So all the rows are here displayed. And that's it for this video. In the next video, I'm going to show you the different attributes, methods, and functions a Dataframe has in Pandas. Welcome back. In this video, we're going to see some basic attributes, methods, and functions that we can use in Pandas. But first, let's learn what are each of them. So first, attributes are values associated with an object, and they are referenced by name using dot expression. So to get to an attribute, we have to use the dot sign. So for example, below you can see that we have a data frame named df, and to get to the columns, we have to use the dot columns. So columns, it's an attribute, and that's how we get this attribute of this data frame. So now we have a function. A function is a group of related statements that performs a specific task. So we've seen functions before in Python. We've seen some Python built-in functions like the max that gets the maximum value of a list, or min that gets the minimum value, or len that gets the length of a list. So those are some Python built-in functions that we can use in Pandas too. And finally, methods are functions which are defined inside a class body. So we haven't talked anything about classes because it's not the main topic in this course. So just keep in mind that functions are inside a class. So when the creators of Pandas built Pandas, they use many classes, and those functions inside some classes are known as methods. So for example, below you can see the head method, and we've seen also the tail method and some other methods so far. As a rule of thumb, when we use methods, we have to write the parentheses, but when we want to get access to attributes, we only write the dot and the name of the attribute. So the method is with dot and parentheses, and the attribute is with only that and the name of the attribute. So enough talk, now let's write some code in Jupyter Notebooks. So here we're going to use the same CSV file we used in the previous video, and we imported Pandas as we did before. Then we read this CSV file with the read_CSV method. And now we show the data frame simply by writing the name of the data frame. So we've seen this before. I'm just reminding you. And now we'll see some basic attributes, methods, and functions that we can use in Pandas. So first, let's check some attributes of this data frame. So first, I'm going to copy the name of the data frame. And now let's check. So the first attribute, it's going to be the shape. So we've seen this before, I believe, and to get to the attribute, we write the dot, and then we write the name of the attribute. So it's shape, so df exams dot shape, and we get the name of the attribute. The first is the number of rows, and the second is the number of columns. So let's go to the next attribute. The next attribute is going to be the index attribute, and as you might expect, we have to write only the name of the data frame, then the dot, and now index. And this is how we get the index of this data frame. So as you can see, this has some form of range. A range, as you might know, has 3 arguments, and actually 2 are necessary. The first is the start. In this case, it starts in 0, and the second is the stop, so the last element, and it stops at 1000. So this is true because here my data frame starts with 0 and finishes with 999. Well, it's 1000 because stops 1 before 1000, and here it increases by 1. So 0, 1, 2, and 3, and so on. So the step is 1. So this is my index attribute. So now let's continue, and now let's get access to the column attribute. So to do so, we write the name of the data frame, and then we write the name of the attribute. So in this case, column, and it has to be written with S, so in plural. So we run this and we get the name of the columns. So as you can see here, we have 8 columns, the gender, race, ethnicity, and so on. And we can use this attribute even to modify the name of the columns, but we'll see that later. And now let's see how we can obtain the data types of each column. To do so, we have to use the dtypes attribute. So we write, well, the name of the data frame again, and then dtypes. And this is gonna give us the type of each column. So the gender is object, and actually from the gender to the test preparation course are objects, while the math score, reading score, and writing score are integers, so numbers. By default, anything that says object is some kind of string. So I'm gonna print this so you can see much better. So here is the data frame again, and as we've seen before, from gender to test preparation has the type object, and as we can see here, all of them are strings. So we can say that objects are the same as strings here. And also anything that says a score here represent some kind of number. So that's why we get here integers. So int 64. So these are the most common attributes in a pandas data frame. Now let's review some methods. So first, let's see the first 5 columns, and as you might know, it's with the head method. So we only write the name of the attribute, the name of the data frame, and then we write the head method, so head and parentheses. So we run this and we obtain the first 5 rows. So we can also obtain some summary info of the data frame by using the info method. So here we write the name of the data frame, info, parentheses, and execute this. So here we have some information about this data frame, and here we have again the data type here, and also how many rows are non-null. So as you can see here, all the data that we have in this data frame are non-null. So there isn't any empty data here in this data frame. Okay, now if we want to get some basic statistics of a data frame, we have to use the describe method. So we write the name of the data frame and write describe. Parentheses, execute this. So we run this code and we have some basic statistics. So first, the count. So this indicates how many rows each column has. So each of them has 1,000 rows. Then we have the mean. So it's basically they sum each of the data here, the numeric data, and then divide it by 1,000 because there are 1,000 rows. Then the standard deviation, the minimum value. For example, in math score, the minimum value was 0. Then 25% represents the percentiles. So this is Q1, 25%, Q2 is 50%, and Q3 is 75%. Then we have the maximum value on each score, on each exam, and we see that the maximum score is 100 on each of them. So the describe method is a useful method whenever we want to get some basic statistics of the data frame, especially of the numerical data that we have in our data frame. Okay, now let's see some functions that we can use in pandas. We can use some built-in functions that Python has in pandas. For example, if we want to get the length of a data frame, we only have to write len, and then inside parentheses the name of the data frame. So we run this and we obtain that the length of this data frame is 1,000. Actually, the length of a data frame indicates only the number of rows. So here I made a mistake, is rows. And this is how we obtain the number of rows of a data frame. So also we can use other built-in functions that Python has, like the max function. So we write max, then the name of the data frame, we run, and in this case we didn't get anything meaningful because we get like a string. But if we write here the index and we write max. As you might remember, if we use this attribute, we're gonna get the list of index. So if we use the max function, we're gonna get the maximum or the highest index here. So run, and is 999. So we can also get the lowest index of a data frame. We only have to copy this, and instead of writing the max function, we write min. So in this case, we get the minimum index, and is 0. So now we can obtain the data type of the data frame. Well, the data frame has a data frame type, but we can verify that using the type function. So we write type, then we write only the name of the data frame, and we run. So here, as you can see, the type of this object is a data frame. And finally, we can use a common function that is the round function. So we write only round, and this has 2 arguments. So first, the object that we want to round, and in this case is our data frame. And the second argument is the number of decimal points that we want to have. So in this case, I want 2 decimal points. So we run this, and we're not gonna get this number of decimal points in this particular example because the numerical data we have here, it's integers, so they are not floats. So this doesn't have any effect. But if you have a data frame with float numbers, you can round those numbers using the round function. And that's it. These are the most basic attributes, methods, and functions that we will see often in Pandas. Alright, now it's time to learn how to select a column from a data frame. So here I have the same CSV file we've been using in the previous videos, and well, let's import Pandas and let's read this CSV file. So I have this in the same data frame, and I'm just showing the first 5 rows. So now, to select one of the columns of this data frame, we have 2 options. So let's see the first option. The first option is using the square brackets. This is the preferred way to select a column in Pandas. And let's see how to select the gender column. So the first one here. So the first thing we have to do is to write the name of the data frame, in this case df_exams, and then open square brackets. So I open square brackets, and now we have to write the name of the column. So we open quotes, and now here I'm gonna copy the name of this column and I'm gonna paste it here. So we have here the name of the data frame and then the name of the column we want to select. So now we press Ctrl Enter to run this code, and as we can see, we have the first column of this data frame. So here we have this, and as you might expect, this is an array. So this is a 1D array, and as we discussed before in previous videos, 1D arrays are series. So we can verify if this is true. So we can do this with the type function. So I'm gonna copy this column, this selection, and now what we're going to do is to use the type function. So we write type, then open parentheses, and then inside parentheses we write the object we want to evaluate. So in this case it's this. And now we run this, and as you can see here, we get a series. And series, just like Pandas data frames, have attributes and methods. So we can access those attributes and methods. And actually, the attributes and methods between a series and a data frames are very similar. So, for example, if we want to get the index attribute of this series, we only have to write the name of the series and then write that and the name of the attribute, so index. So we run this and we get this index in form of a range that starts with 0 and ends with 1000. So another method that share Pandas and series is the head method. So we can also get the first 5 rows by writing that head and parentheses. So as you can see here, we get the first 5 rows of this series. Alright, that's it for the first syntax. This is my favorite syntax, and actually most people use it because it's the most practical. And now it's time to see the second syntax to select a column from a data frame. So this syntax involves writing the dot sign, which is here. So let's say we want to get the same gender column. So we write the name of the data frame followed by that and the name of the column, so gender. In this case, we don't need to open quotes and we don't need the square brackets. So we run this code and we get the same series. So it's here, and probably now you might be thinking that this is more practical than the first syntax, but this syntax has some pitfalls. So now let me show you here. So what if you want to get one column that has 2 words? For example, what if you want to get, let me show you here, this column that has as name math score. So now let's try to get access to this column. I'm gonna copy this column name and now scroll down and now let's try. So I'm gonna write first the name of the data frame and now the dot. So to get access to this or to select this column, we have to write the column name. So this is the column name. But as you can see, if I run this, we get an error because Python doesn't work like that. In Python, when we have 2 words, we usually add a underscore. So that's how Python understands this, that this is a variable. But if it's like this, Python will not understand what you're trying to do. However, if you use the first syntax, so the square brackets, you won't have this problem. So let me show you here. Now I'm gonna write this, I'm gonna copy, and now I'm gonna paste it here. And instead of having this only dot notation, I'm going to open the square brackets. So open square brackets and then add the quotes. So as you can see here, the column names has a string type. And now Python knows that this is a string. And now if you delete this dot sign and you execute this, you get this column without any error. So this is one of the advantages that the square brackets has over the dot sign. And that's it. In this video, we learned how to select one column from a data frame. And in the next one, we're going to learn how to select 2 or more columns from a data frame. Okay, in this video, we're going to learn how to select 2 or more columns from a data frame. So as usual, we're going to start by importing pandas and reading the CSV file we've been using so far. So we execute these 2 lines of code and we get here the data frame. So what we're going to do in this video is to select 2 random columns from this data frame. So first, let's pick some columns. So I want to select the gender column and also the math score column. So to select these 2 columns, we have to use the square brackets again. So here, in this case, we have to use 2 square brackets to select 2 or more columns. So to do this, we have to write first the name of the data frame. So it's df_exams. And now we open square brackets. So we write 1 and 2 twice. So we have 2 pairs of square brackets, and inside we have to write the name of the columns we want to select. So we said that we wanted the gender column, so we write gender, and the second column that we chose was the math score. So I open these quotes and now I write math score. So here I have these 2 columns, and by the way, the order that we write these columns is the same order that we're going to get the data frame. I mean, we can define the order of the columns inside this square bracket. So here we're saying that first is the gender column, and second it should be the math score column. So now let's run this, and as you can see here, we obtain first the gender column and second the math score column. So here we can see that it's a data frame and there are 999 rows. So now we can verify that this is actually a data frame by using the type function. So let's check if this selection is a data frame. So now I'm going to copy this, and here let's check out the data type of this selection. So here I paste it, and now we use the type function. We open this parenthesis, and now we execute this code, and as you can see here, we got that this is a data frame. So here, one little detail I want to tell you is that when we use these two square brackets or two pairs of square brackets, we're always gonna get a data frame. But when we use only single pair of square brackets, as we did in the previous video, we get a series. So one pair of square brackets is for a series, and two pairs of square brackets, it's for a data frame. Okay, now to continue with the video, I'm gonna select two or more columns using these two pairs of square brackets. So now let's choose the columns that we're gonna get. So in this case, I'm gonna get the gender column and all the scores that we have here. So the math score, reading score, and writing score. So to do so, first I'm gonna copy this first selection with it to have it as a reference, and now I'm gonna paste it here. So here, so far, we have two columns. So let's add the two remaining columns. So here, an easy way to write these columns is just by copying this in the data frame, and here we can paste it. So instead of writing those names, we can just paste it here. Now I delete and I put it inside quotes. So here inside quotes, and here we have it. So here, as I said before, we can change the order of the columns. We just have to, for example, here I cut this, and let's say we want to have the writing score in the beginning. So here I paste writing score, and now what we're gonna get is first the gender column, then the writing score column, and then the math score and reading score columns. So now let's run this code. And as you can see here, we have this data frame in the order that we defined here. Okay, now you might be thinking if there is a way to select two or more columns using the $sign. So let's check if that's possible here. For example, let's say we want to get the gender and the math score column using the dot notation. So here I have it. And as you can see here, this doesn't look right, because you have two strings separated by a comma, but you don't have a list, you don't have square brackets. This is probably gonna fail. So let's check. I'm gonna run this code, and as you can see here, we got an invalid syntax. So it's a syntax error. So as you can see, we cannot select two or more columns with the $sign. And this is one of the disadvantages that the $sign has over the square brackets. This is why most people prefer to use the square brackets instead of the dot notation. And that's it for this video. In this video, we learned how to select two or more columns from a data frame. Okay, in this video, we'll see different ways to add a new column to a data frame. So here's the same student's performance data frame. And as you can see, we have three columns with scores: math score, reading score, and writing score. So let's say we want to add a new score. So in this case, let's add a language score. So to add a new column in spreadsheets like Google Sheet or Microsoft Excel, we'll simply insert a new column and that's it. But in Pandas, we have to use different methods or different ways to allow us to insert a new column. So let's see how to do it here. So first, let's add a new column with a scalar value. So a scalar value is simply a single value, and in this case, the column is going to have one single value. So all the rows is going to have the same value. So to do so, we're going to have to select this imaginary column because this column doesn't exist so far. So what we're going to do is to select a column as we will do with any other column. So first we write the name of the data frame, in this case df_exams, and then we open square brackets and open quotes, as we will do in any column. So here, instead of, for example, writing math score, I'm going to copy this. Instead of selecting math score, we have to write the name of the column we want to create. So in this case, let's write language score. So this is a new column we want to create. And now we have to assign to this new column, we have to give it a new value or a new scalar value. In this case, I'm going to add a value of 70. So now if we run this code, we're going to see that nothing happens. But if we now show the data frame, we're going to see that we have a new column. And this column is named language score. And the value that this column has is the same value. So it's 70 in all its rows. So we have 70 in row 0. And if we scroll down, we're going to see that it's 70 in all the rows. So even in row 999. But it's a bit weird that in an exam you will have all the students with the same score. So what you will usually do is to add some different values to this column. So to do this, we have to use arrays. And to create arrays, we have to use NumPy. So here in the second way to add a new column, we're going to use arrays. So in this case, we have first to see how many rows this data frame has. So in this case, it has 1000 rows. And this is important because the number of rows has to match with the number of the array we're going to create. So let's create this array. And first, let's import NumPy. So we write import NumPy as NP. So we run this code. And now we imported NumPy. So now we have to create an array of 1000 elements. And to do so, we're going to use a method called arrange. So it's written like this, arrange. And this gives us a range of numbers that start with the first argument that I'm going to write 0. And the last argument that in this case, it's gonna be 1000. So these are the limits of my ranges. So I execute this, and as you can see here, it starts with 0 until 1000. So to verify the length of this range, we have to use the length function. So as you can see here, the length is 1000. So the array has 1000 elements. So now I'm gonna assign this to a new variable. And I'm going to name this variable language score. So language underscore score. So we execute this. And here I was planning to see the length of this array. So I quickly do it here as we did it before. So length, and now we have the length of the array. So now we have to add a new column to a data frame with this array. And to do that, we have only to use the same way we did before. So first we write the name of the data frame, and then we make the selection. So this selection is going to be with the new column. Well, in this case, it's not new because we already created it, but let's imagine it's a new column. So it's language score. And now we have to set the array to this column. So we write language score here, and we set it to this new column. So now to see the results, we only show this data frame. And as we can see here, we have a new column, and this new column starts with 0 and it ends with 999. So it doesn't have a single value anymore, but now it has a range of values. And now there is a little detail we have to take care of. So scores are supposed to be between 0 to 100, and we have here from 0 to 999. And also here we have a sequence of numbers, so it's from 0 and then 1, and it increases by 1. And usually in scores you will see that students have random scores, so we have to create here an array with random numbers. And to do that, we have to use NumPy again, but here we have to use a different method. In this case, the method is named random.randint. So let's write it here, np.random.rand and then int. So the first argument is the lowest value of these random numbers. And by the way, these are random integer numbers because scores are usually integer numbers. And in this case, I'm going to set this to 1. And the second score is the highest number or value in these random numbers, and I'm going to set it to 100. And the third argument is the size. In this case, we want an array of 1000 elements, so we set the size to 1000. Now we execute this, we run this, and I'm not going to see this array again. I'm just going to check that it has the length we want by using the length function. And here we have 1000 elements. So now let's create a new variable and store this in the variable. So here this is going to be int and then language underscore score, and this is going to be our new variable. So here one little detail you should know is that the first argument is inclusive and the last one is exclusive. So this means that if we here, let's say we get the minimum value of this new array, we're going to get that the minimum value is 1 because this first argument is inclusive, which means that it can be included in this new array. However, if we print now the maximum value of this array, we're going to get that 100 is not there because it's exclusive, which means that this second argument shouldn't be included in this array. Okay, finally, let's insert these random integer numbers in the new column that we created. So we have to just use the same way we did it before. So here I copy and now I paste it. So here, instead of assigning this language underscore score, I'm going to use this int language underscore score. So here I'm going to run this code, and as you can see here, we have the same column, and we have now this data that is random integer numbers from the row 0 to the row 999. So now this new data looks more like scores, like real scores, because these are random numbers and these are between 0 and 99. And that's it. Now one more little detail I want to share with you is how to create random float numbers, because before we created random integer number, but if for some reason you want to create random float numbers, there is a way how to do it with NumPy. So we only write np, then .random, then .uniform, and the arguments are the same. So the minimum value, then the maximum value, then the size, which is 1000. Then you run this, and well, it's similar to the one we got before, but now we have float numbers. And that's it. In this video, we learned different ways to add a new column to a data frame. Alright, now it's time to see some operations we can perform on data frames. So here we have the same data frame, df_exams, and here we can apply some common operations to the numerical columns like math score, reading score, and writing score. So let's see how to do this in Pandas. So first we're going to see how to make operations in columns. So our first task is to calculate the total sum of a column. So let's pick first the math score and let's calculate the sum of this column. So to do that, we have first to select a column, and as you might remember, to select a column, first we have to write the name of the data frame. In this case, df_exams. Then we open square brackets and then write either single or double quotes. Then we have to write the name of the column, and in this case it's this one, math score. This is the column we want to select. And now instead of selecting, we're going to perform an operation. So in this case, I want to calculate the total sum of this column, and we have to use the sum method. So we write dot sum in parentheses, and this is how you calculate the total sum of this column. So to verify this, we run this code, and here we got 66,000, and this is the total sum of this math column. Great. Now we can make some other operations you will do in Excel. For example, we can calculate the number of rows using the count method. So here we can easily do that. I'm just going to copy this one. And now instead of writing the sum method, we write count. So here count, and now let's see. So we see 1000 rows. And yeah, this is correct because this data frame has 1000 rows. So now we can calculate the mean of this math score column. We have to copy this one, now paste it, and instead of writing count, we have to write mean. And here we got the average value of this math score column. So to get the average, we have to sum all the rows in this math score column and then divide it by the total number of rows. In this case, 1000. And this is how you get this mean value. Then we can get other operations using the method. So here, for example, we can get the standard deviation by writing std. So we execute this, and the standard deviation of this math score column is 15, and we can get also the maximum and minimum value. Let's do it quickly here. So first the max and then the mean value. You can actually do it with the Python built-in function, but we can also do it with the methods. So here I run, and as you can see here, the minimum value of the math score is 0 and the maximum is 100. Okay, now I'm going to show you a quickly way to make the same calculations using the describe method. I think we saw the describe method in previous videos, but in case you don't remember it, I'm going to write here the name of, actually we only need the name of the data frame. We don't need the name of a specific column. We only need the name of the data frame. And now we can use the describe method. So we write that describe with parentheses. And now we got like a summary table with some important statistical values. And here we have the count, the mean, the standard deviation, the minimum and maximum value. And as you can see here, we got all of this with one method. Okay, so far so good. Now, instead of making operations in columns, we're going to learn how to make operations in rows. So now let's calculate, let's say, the sum of the math score, reading score, and writing score. To do so, we have to make some selections, and in this case, we have to make some independent selections. So to show you, I'm going to copy the name of these three columns. I copied it, and now I paste it here. And now we have a math score, reading score, and writing score. So now let me delete that sign, and now we have to make some independent selections. So first we write the name of the data frame, so df exams, and now to make the selection we open square brackets and quotes. So now let me do this quickly in the others. Now here, so I open square brackets, and now let me do it here too. And now it's ready. So here we made some independent selections, and now to make to calculate the sum in a row, we have to use the plus sign. So here, the plus operator, we have to write it here and here. So basically here we're making sum in each row. So to verify this, we run this code, and as you can see here, we got the sum of the scores column. So here let's verify fast the sum of the first row, and it's 72 plus 72 plus 74. So 72 with 72 is 144, and with 74 is 218. So here we have it, and it's correct. So now let's do something else. So now instead of just summing these three rows, or actually these three columns, what we're going to do is to calculate the average to get like an average score. So here, let me copy this, and now here we're going to calculate the average by summing this and then dividing this by 3. So this is how we calculate the score. And now let's assign this result to a new column. To do so, we only write equal, and then, as you might remember from previous lessons, we have to add a new column by writing the name of this column. So we do that, writing the name of the data frame, and then making like a selection. So we open square brackets, then open quotes, and here we write the name of the column that we want to create. So this is the same as we did in previous lessons where we added a new column. So in this case, I'm gonna name this new column as average, and I'm gonna execute this. And now to verify that this new column was created, I'm gonna show this data frame here below, and here is our data frame. So now in the last column, you can see that there is a column named average, and it has the average value of this math score, reading score, and writing score. And now here we can control the number of decimals. We can just use the round function and write the number of decimals we want to get. So in this case, I want only 2 decimals. So I run this, and as you can see here, our data frame looks much better because we only have 2 decimals. And that's it. In this video, we learn different ways to make operations in columns and rows on data frames. Alright, now let's have a look at the value counts method. So far, we have seen how to count the number of rows in a data frame. So for example, if we want to count the number of rows in the gender column, we either use the length function, so we write length, then the number or the name of the data frame, and we only have to write the name of the column. So as you might remember, this gives us the number of rows. And we can also use the count method. So here we write count and we get the number of rows. But what if we want to count the gender elements by category? So female or male. What if we want to know how many female and how many male elements are in this gender column? So this is when the value counts comes in handy. So we can use this method to count each category of the column. So to use this method, we only have to write the name of the data frame followed by the column that we want to count. So in this case is the gender column, and then we have to use the value underscore counts method, as you can see here. So now we execute this, and as you can see here, we have not only the total rows in this gender column, but now it's divided by category. So we have that there is 518 females and 482 males. So this is how the data is spread in the gender column. So now we can do more with the value counts method. So we can get the percentage that each category represents in the whole column. So here I'm gonna copy this. And now to calculate the percentages, also known as relative frequency, we have to add an argument named normalize. So we write normalize equal to true. And then we execute this, and as we can see here, female represent 51% of the total observations in the gender column, while male only represents 48% of the total observations. So as you can see here, the value count method is useful when you want to have a look at the data by category. Okay, now let's see another example, and in this case, let's pick a different column. So here I'm gonna choose this parental level of education column. I copy this, and now let's calculate, let's count the elements by category. So here I'm gonna write the name of the data frame, df exams, and now I open square brackets, quotes, and here I paste this column. Now to count the elements by category in this column, we use the value underscore counts method. So we run this code, and here you can see how the data is divided in this column. So most people have some college level of education, while just a few people have a master's degree. And now if we want to get the percentages that represent each category, we again use the normalize argument. So we write normalize equal to true, and now we're gonna get the percentages. So we can see the percentages, and if we want to round this to 2 decimals, we use the round method. So we write that round parentheses and now 2 decimals. And as you can see here, we round it to 2 decimals. And that's it. Now you know how to use the value counts method. Okay, in this video, we're gonna see how to sort a data frame using the sort underscore values method. First, let's import and read the CSV file that we've been working with in this tutorial. And now let's sort the data frame. So here we have the data frame, and as you might remember, it has these 3 numerical columns, and now I'm going to sort it using one of these columns. So let's use the sort underscore values method, and first I'm going to write the name of the data frame, which is df underscore exams, and then write sort underscore values. Now I open parentheses, and now I can use this help here, and as you can see, the only mandatory argument is by. So we can use this one by, and this one we have to specify the name of the column we want to sort by. So in this case, I want to sort by the math score. So I'm choosing this numerical column to start with. So I'm going to write math score. Actually, I'm going to copy this one and paste it here. So by math score. And sorting this data frame is as simple as that. Now we can run this code. And as you can see here, the data frame was sort ascending by default. So it starts with 0 and it ends with 100 in the math score. So this is how the sort underscore values behave by default. And here one little detail, you don't need to specify the byte word. We can omit it and we run this, and as you can see here, it still works. So here we can modify the default behavior of the sort underscore values method. We only have to add a new argument, and it's the ascending argument. So let me show you here. I'm going to copy this one first and show you here. So in this case, we're going to sort descending by the same column. So we only write comma, and then we specify the ascending argument. So we write ascending equal to, and here I want to show you something in this little help here. Here the ascending is set to true by default. This means that is ascending by default, but we can change this default behavior by setting ascending equal to false, and that's what we're gonna do here. Ascending equal to false, so it means descending. And now I'm gonna run this one, and as you can see here, is sort descending by the math score column. So here it starts with 100 and it ends with 0. But that's not all. We can do much more with the sort underscore value method. So first, I'm going to show you here how to sort by 2 different columns. So here, let's copy and paste this one. So in this case, we're going to sort descending by multiple columns. So instead of writing only math score, we're going to add here one more column, and it's going to be the reading score column. So here I copy this one. I'm going to copy and paste it here. But first we have to add the square brackets, because as you might remember, when we write two or more columns, we need the square brackets. Now I write comma and I paste this reading score. Now I add quotes, and that's it. That's everything you have to do to sort by multiple columns. Now I'm going to run this one, and as you can see here, it was sort descending first by the math score column and then by the reading score column. So the priorities are set here in the list that we included here. So first is the math score column, first priority, and the second priority is the reading score column. And that's what you can see here. Now I'm going to show you a little detail here. Let me copy the df_exams, and if I print this one, you can see that the changes we made weren't updated. So this here, the math score column, has the original values. This happens because the sort_values method, like many other pandas method, only creates a copy of the data frame. So here we obtain a copy. This one is a copy, but it doesn't update the values of the data frame unless we add a new argument, which is the in-place argument. So I'm going to show you here, but first I'm going to delete this df_exams, and now I'm going to copy this one and show you how to update the values of this data frame. So here I'm going to copy, those are the same values, but now I'm going to add a new argument, which is the in-place argument. So here I write in-place equal to, and now I'm going to show you the default value. So here the default value of in-place is false. This means don't update the data frame, but only create a copy. But if we set it to true, it means update this data frame. So here I'm going to set it to true to update the data frame. So here I write true, and now I run this, and apparently nothing happens. But if now we print the df_exams data frame, we're going to see that we have the data frame sorted. In case you don't want to add the in-place argument and you want to update the values of the data frame, you have another option that we used before, which is overwriting the values of this data frame. So for example, you can only delete that in-place argument and write df_exams equal to this. So this is overwriting the values. But in this case, we're not going to do that. We're going to add the in-place argument, as you can see here. Finally, we're going to see how to sort, but now not with numerical data, but with text. So as you can see here, we before sort this data frame by the math score column. And this one has this numerical data, but in this case, we're going to sort it by the race ethnicity, which has this text. So we're going to sort this one. So first we're supposed to get group 1 and then group B, C, D, E, and so on. So let's do this here. I'm going to scroll down, and first we have to write the name of the data frame, followed by the sort_values method, and now specify the name of the column. So here I'm going to copy race ethnicity here. Let me copy here, and it's done. Now I have the name of the column. I'm going to set to ascending to true. And now the new argument we have to add to sort this is the key. So I add key, then equal to, and in this case, we're gonna use the lambda function. I'm not sure if you're familiar with the lambda function, but it works similar to an average function we've seen before in the Python crash course. But in this case, it's gonna behave a little bit different. So let me show you here. First, you have to use the lambda keyword. So we write only lambda. And now we should write the object that is supposed to return. In this case, I'm gonna write col, that stands for column. And then we have to write column and specify the operation we have to make over this variable. So in this case, I want to write column or col, and then access the string attribute. So I write .str and then use the lower method. So what we're saying here is get the string values of the column and then transform it to lowercase. So here we get the textual data in lowercase. And with these three arguments, we're saying sort the values inside the race ethnicity column and sort it ascending. And then sort the textual data of this column in lowercase. So here we have this A, B, C, D, E in uppercase, but we're gonna get it in lowercase and sort it by this text data. So now let's run this one and let's see the results. So as you can see here, we have this race ethnicity column and its order ascending. So here we got the A and B and C and D and so on. And that's it. These are the different ways to sort a data frame using the sort_values method. Welcome back. In this video, we're gonna see different ways to make pivot tables. If you're an Excel user, probably you made many pivot tables in the past. In Pandas, we can also make pivot tables. And in this case, we use two different methods, the pivot method and the pivot_table method. In this video, we're gonna see the difference between the two of them. So first, let's see what's the pivot method. So the pivot method reshapes data based on columns values, and it doesn't support data aggregation. So this means that this is not the regular pivot table you will see in Excel, because you can only reshape data with the pivot method and you cannot do anything else. To explain you better what the pivot method does, I'm going to show you an example. So here we have a little data frame, and this one has 6 rows and 4 columns. And as you can see here, there are many duplicate values. For example, in the column foo, the 1 value is repeated at least twice, and the same goes for the 2 value. Also in the column bar, you can see that the A, B, and C is duplicated. So when we have this type of data frame, we can reshape it to have a different view and to make a better analysis. In this case, we can use the pivot method, as I'm going to show you right now. You only have to write the name of the data frame followed by the pivot method and then specify 3 arguments. So the first one is the index. In this case, I'm going to reshape this data frame choosing the column foo as an index. This means that the column foo will be in the position where is right now the numbers from 0 to 5 on the left. Next, you have to define the column. So these are the new columns that we're gonna see in our new data frame, the one that we're going to reshape. So in this case, I'm selecting the data inside the bar column as new columns. This means that A, B, and C will be the new columns in our new data frame. And finally, we have to choose the values we wish to show in this new data frame. So in this case, I'm choosing the best column, so all the values inside there will be shown in our new data frame. So this is the column that I'm selecting. And now I'm going to show you the result of this pivot method. So here it is, and as you can see here, we have the foo in the index, as I told you before, and the A, B, and C that are data from the bar column now are columns in this new data frame. Also, all the data inside this base column is the only data that is displayed in this reshaped data frame. And now let's see why it's sorted this way. So why 1 is here, 2 is here, 3 is here, and so on. So here the value is defined by the index or row and the column. So between 1, index 1, and column A is 1. And why that happens? Because if we go to our previous data frame or the original data frame that is here, we can find that here is 1, A, and the value that corresponds to that pair is the number 1. So let's pick another one, for example 5 here. we have 2 and B. And if we go here to our original data frame, we have that 2 and B, the value that corresponds to that pair is 5. So that's why this value is here. And that's how this new data frame was reshaped. Okay, and finally we have the pivot underscore table method. And this one creates a spreadsheet style pivot table. So this is similar to the pivot table that we will find in Microsoft Excel, for example. And this one supports data aggregation. And to explain you more about the pivot underscore table method, as well as the pivot method, we're going to see some examples in the next video. And this time we're going to write some code so you can understand much better what we're doing. Alright, now it's time to see how the pivot method works in action in Pandas. So first, as usual, we import Pandas as PD. So here I import this library, and then we're going to use a different dataset to work with this pivot method. So to read this dataset, we use the PD read underscore CSV method. And inside parentheses, we write the name of this dataset. So in this case is gdp.csv that you can find in the notes of this video. So this is the new dataset, and now let's have a look. I'm going to run this one, and as you can see here, we have data about GDP per capita that is in this column, and basically this is how the GDP grow over the years for each country. So here I'm gonna tell you which are the columns we're going to use for this example. So first we're gonna use the country column that contains data about different countries. Then we're going to use the year column that, well, contains different years, and the GDP per capita that it's in this column. So basically what we want to do in this exercise is to obtain a different view of our original data set. So this data set that we're reading here with Pandas has this view, but we want to get a different view to have a better analysis. So the goal of this exercise is to see the evolution of the GDP per capita over the years for each country. And then we're going to put the country names in the columns. So the only data we're going to show in our new data frame is going to be the GDP per capita that it's here. So I'm going to show you now this with code, and let's write it here. But first, let's assign a variable to this data frame. So here I'm going to write df underscore GDP. So this is the name of my data frame, and now I'm going to show it, and it's here. So now I'm going to copy this data frame, and to use the pivot method, I'm going to paste this one, and now write that pivot. Now we open parentheses, and now as you might remember from the previous video, we have to introduce 3 different arguments. And if you don't remember the 3 different arguments we have to introduce here, you can only press the Shift and Tab keys on your keyboard and you will get this. And here you can see the 3 arguments I'm talking about. So first we have to write the index argument. So we write index, and as I told you before, I want the year column to be the index of my new reshaped data frame. So I'm gonna set this year as the index of my new data frame. So I write here year. Next we write comma and press Shift and Tab to show this. So the second argument is the columns. So we write columns, then equal and open quotes. So here, as I told you before, I want the countries here listed in the country column. I want each country to be an independent column. So for example, here, let's say we have the United States. So I want the United States to be column number 1, then column number 2, China, then Australia, then Spain, and so on. So each country should have one independent column. So that's what we want. And to get that, we have to set the country column here to the columns argument. So here country, and that's it. Now again, Shift plus Tab to show this window here. And now the third argument is values. So here I'm going to write values equal to open quotes. And here the only data I want to show here in my new data frame is going to be the GDP per capita, which is the one that is here. And now I'm going to copy this one and paste it here. So remember our goal. Our goal is to see the evolution of the GDP per capita over the years for all the countries listed here in this column. So here we're gonna execute this code and let's see the result. So here, Control Enter, and as you can see here, I have the new view of this data frame and it looks much better. It's more readable because we can see the GDP evolution over the years for each country. So now let's verify if everything is correct. So here we have the index year and here we have the year as index, so everything's fine. Then the columns should be country, and now we have each country in the columns, so it's correct. Next, the values are the GDP per capita, and yeah, we have here the intersection between the row and a column is a value that corresponds to the GDP per capita of that country in that year. So everything is working fine. And there you have it. This is how the pivot method works in Pandas. Okay, now let's see how the pivot underscore table method works in Pandas. So in this case, we're going to work with a different data set, and to read it, we're going to use the method pd read underscore Excel, because in this case, the dataset is not a CSV file, but an Excel file. So we use read underscore Excel for an Excel file. So in this case, the name of this dataset is supermarket underscore sales dot xlsx. And this is what we're going to see after you run this. And here you can see that we have different columns about what a specific person bought in a supermarket. And here, well, we have the branch, the city, the gender, and different data. So here, to make a pivot table, we're going to first name this data frame. And I'm going to name it df underscore sales. And now I'm going to show it here. And okay, now it's here. Okay, the goal of this task is to see how much female and male spend their money in this supermarket. So to do that, we're going to use the pivot table method in Pandas. So first, I'm going to copy this data frame. And now I'm going to paste it here. And now we're going to make a pivot table and add an aggregate function, because remember that the pivot underscore table method allows us to add an aggregate function, and the pivot method doesn't support that. So we're going to use the pivot underscore table this time. And now we're going to introduce some important arguments. So the first one is the index. And in this case, if we want to see how much male and female spend in this supermarket, the index is going to be the gender. So here, I'm going to copy gender here, and it's going to be here. Index equal to gender. So this is the first necessary argument. And the second one is going to be the aggregate function. So we have to write A, double G, F, U, and C, and then equal to, and then write the aggregate function we want to perform. So in this case, it's going to be a sum. So we write sum, and now everything is ready. So what we're supposed to get here is the information about the sales here in this data frame but now divided by gender. So we have the female category and then the male category. So let's verify this. I'm going to run this one. And as you can see here, we have this summary table or pivot table, and now it's divided by gender. So we can see how much female is spent here in the total column, and also how much male is spent also in the total column. And here in the quantity column, we can see how many products they bought, how many products female and male bought in this supermarket. And one detail you might have noticed is that only the columns that contain numerical data are displayed here. So for example, here branch and city that contain only text aren't here in this pivot table, because here in the aggregate function argument we indicated that we want to sum, and when we sum values we cannot sum text but only numerical data. So only the columns that have numerical data are displayed in this new pivot table. Okay, that's our first pivot table, and we can do even more. For example, we can select a pair of columns that we're interested in. So let's say we only care about the quantity and the total column. So we want only those columns. So we can get that. I'm gonna copy this one. And to show you how to get only those two columns, I'm going to add a new argument. So here I'm going to write, and in this case, the name of the argument is values. So I write values equal to, and in this case, I'm going to select the quantity and the total columns. So I open square brackets because I'm going to select two or more columns, and inside I write the name of the column. So first quantity, I write here, and then total. So here too. So we're gonna get the same pivot table, but in this case only the quantity and the total columns are gonna be shown in this table. So I'm gonna execute this one, and here I got an error because I didn't include this comma, so I'm gonna add it here, and now everything should be fine. And yeah, we got the same pivot table, but only the quantity and total columns are displayed here. And here we can clearly see that female spent more than male in this supermarket. But we can get even more detail here. So far we know that female spent 167,000 in this supermarket. But with pivot tables we can even know in which product lines this money is spent. So let me show you here. We can see how the money is spent in this product line column. So we only have to add a new argument to this pivot table method. So I'm going to show you here. First we copy this, and now I'm going to paste it here, and we're going to make a pivot table that says how much male and female spent in each category, or well, product line. So we add a new argument, and this one is going to be the columns argument. So I write columns, then open quotes, I add the comma, and here I write the name of this column that is product line. So I scroll up, I copy this column, and then we're gonna see in which category is spent the money. So health and beauty, or sports, and so on. So now I scroll down, and here I paste it. And before I run this code, here we only want to display the total because we only want to see where the money goes, not the quantity. So only total, so I delete the square brackets too. And with total, we're gonna see where the money goes divided by gender. So here I run because it's ready. And now, as you can see here, we can see how much female and male spent in each product line. So we can quickly see, for example, that female spent more money on fashion accessories than male, and that kind of makes sense. And also in sports, women spent or female spend more money than male. So we could easily see all of that by using the pivot underscore table method in Pandas. And this is similar to the pivot table you will find in Excel. And that's it. That's how you make a pivot table in Pandas. Alright, before showing you how to make visualizations with Pandas, first we have to check the dataset, and also we have to make a pivot table so we can easily make the plots with Pandas later. So first we have to import Pandas to read this CSV file, and well, I have this import Pandas as PD, so we just run this code, and now let's read this new dataset. So as you might remember, to read a CSV file, we have to use the read underscore CSV method. So we write pd.read underscore CSV, and then we write the name of the CSV file. So in this case, the name is population, and I'm gonna use this population underscore total.csv. So I pressed tab to get this the name. So we have now the name, and now I'm gonna assign this to a new variable. So the variable is gonna be df underscore population underscore row. So this row data, and now we're gonna have a first look at this data set. So I paste this, and now I'm gonna run this too. And now we have this data frame. So here, as you can see, we have the population of many countries throughout the years. So for example, we have China here, United States, and India. So we have the population, and here I wrote the name row because this data set was extracted using some web scraping techniques, and then it wasn't modified. So now we have to make some changes to reshape this data frame so we make it easy for us to make visualizations with Pandas later. So what we have to do here is to make a pivot table to reshape this data frame, and that's what we're gonna do here below. So we're gonna make a pivot table, and we're gonna use the pivot method. So as you might remember, the pivot method returns a reshaped data frame organized by given index column values, but it's a pivot without aggregation. So this is what we want. So we only want to reshape this data frame. So we're gonna start by dropping null values. So we do that by writing the name of the data frame, and now I'm gonna just copy the name and I paste it here. And now to drop null values, we have to use the drop NA method. So I write drop NA, and then we have to run this. And as you can see here, we have the result, and it's a copy from this data frame. But if we want to save the changes that we make to the data frame, we have two options. The first option is to use the in place argument. So I write in place and then set this to true. So if we do this and we run, all the changes that we make to the data frame are gonna be saved. And the second option is to do something like this, to overwrite the content inside this data frame. So we do something like this. We write df underscore population underscore row is equal to the same data frame, but that drop NA. So we're overwriting the content inside this data frame. So I'm gonna choose the first option just to reduce some code. So I write in place equal to true, and now I run, and this new data frame shouldn't have any null values. Okay, now it's time to make this pivot table. So first I'm going to show you what I'm going to do so we have a better idea before writing the code. So here we have the original data frame, and what we're going to do is to reshape this data frame. So I want the year to be in the index. So the year column, I want it to be here in the index instead of 0, 1, and so on. And then I want the country column, or the values inside the country column. I want it to be here in the columns. So for example, I want China here in one column, then United States in another column, and then India in another column. And I want the population data inside the data. I wanted this to be the only data here. So to do that, we have to use the pivot method, and that's what we're going to do here below. So let's do it here. So first we have to write the name of the data frame, which is this one, and then write dot pivot. Then we open parentheses, and here let's see the arguments that this pivot method accepts. So I press Shift and Tab to get this helpful, let's call it cheat sheet. And now we have the arguments that this pivot method accepts. So first is the index, then the column, and then the values. So as I told you before, the index, I want it to be the year column. So we have to write index equal to, open quotes, and I write year. Then comma, and let's check another argument. So the next argument is the columns. So I want the columns to be the country, so the data inside the country columns. So here I write columns, then I open quotes, and here I write country. So country. And now the last one I think is values, and yeah, it's values. So I want the values to be the population data. So let me see if that's correct. And yeah, it's here. So population, and I'm going to press enter here so it looks much better. And now population, it's here. So I have the three arguments, the index, the columns, and the values. And now I'm going to reshape my original data frame. So here I press Control Enter. Now, as you can see here, we have the countries in the columns. So here we have many countries. It's from the first country, Afghanistan, to Andorra, Argentina, Uruguay, and many other countries. So we have also the year. So it's here, the year from 1955 to 2020. So we can see here the evolution of the population throughout the years for all the countries in this data set. But as you can see, there are many countries. So what we can do here is to select just some countries so we can simplify our visualizations later in Pandas. So here I'm going to select some columns, but first I'm gonna name this new data frame. I'm gonna give it a name. So I'm gonna name it df_pivot. So this is my new data frame. Now I'm going to rearrange this, and now it looks much better. So now I'm going to run this, and now let's select some countries. So I copy this pivot data frame, and now we open square brackets, double square brackets to select two or more columns. And here let's write some countries. So first United States, then let's say India, then China, two more countries, Indonesia, and last but not least, Brazil. So here we have the 5 countries. So I run here, and we have these 5 countries and the population from 1955 to 2020. So great. Now we simplify this data frame, and now I'm going to overwrite the content inside the data frame, df_pivot, and I'm going to write here df_pivot equal to df_pivot, and with this selection. So I'm overwriting the content. So I press Control Enter, and our new df_pivot is here. So we have it here, and now I'm going to show it to you. And this is our new df_pivot data frame. And that's it. Now our data is ready. So we can use it to make great visualizations with Pandas. And that's what we're gonna do in the next video. Okay, now it's time to make some visualizations with pandas. And here I have the data frame that we created. This is the pivot table we created in the previous video. And as you can see here, we have 5 countries in the columns. And here we have the year in the index from 1955 to 2020. So what we're going to do now is to make our first visualization. So I scroll down here. And the first one is going to be line plots. So here, first to make this visualization, I'm going to copy the name of the data frame and I paste it here. So now to make plots with pandas, we have to use the plot method. So we write .plot and now I open parentheses. And one necessary argument we need to introduce is the kind argument. So I write kind now equal to, and here I have to write a kind of plot we want to make. So in this case it's a line plot, so we write line, and this is actually the mandatory argument we have to introduce here. And now we can run this code. So I press Ctrl Enter, and as you can see here I have the line plot. So in this line plot we can quickly see the evolution of the population throughout the years. For example, China and India, which are green and orange lines, they had some fast growing population, while United States, Indonesia and Brazil, they have a lower population, and also the population didn't change so much in the past 50 years. Here we can add more arguments to this plot method to customize this line plot. So here we can introduce another argument, which is the X label. And this X label is what you can see here. Here, when we created this line plot, by default, it was assigned this year label, but we can change it. So for example, let's say we want to write year, but now with capital letter. So we write year here. And now let's say we want to add a new label here in the y-axis. So here we have only to write y label and then equal to open quotes, and here we have to write the name we want. So in this case I'm going to write only population, and finally we can also add a title. So we can add any title we want. In this case I'm going to write the name of the argument first, title, then equal to, and then the name of the title is going to be, let's say, population from 1955 and to 2020. So this is the title. So let's run this. And now as you can see here, we got the title, population 1955 to 2020, and the X label and Y label were modified too. Finally, we can add one more argument. In this case, the argument is the size of the figure. So to change the size of this figure, we can add the argument named fig size. And this is a tuple, so we have to open parentheses. And now to edit the size, we have to add 2 arguments. The first is the size of the x-axis, and the second the size of the y-axis. So in this case, I'm going to set it to A and then 4, which means that the x-axis is going to be large, while the y-axis is going to be short. So here I'm going to run this code and let's check it out. So here the figure has a different size, and that's how you can customize this line plot. Okay, now let's make a bar plot with pandas. So the first thing we have to do is to select only one year. So the bar plot only accepts just 1 year, and we can plot there the population of different countries. So let's select 1 year of this data frame we have before. So I'm gonna copy the name of the data frame so you can check it out again. So this is the data frame, and we're going to select 1 year. So to do that, we have to use the index attribute and then the isIn method. So first I'm going to show you the index method in case you don't remember. So here the index attribute allows us to see all the index in this data frame. So we have here from 1955 to 2020. So that's what the index attribute does. And now if we use the isIn method, we can filter out some index. So here, let's say we want to select only the 2020. So I copy 2020. And now here I write equal to, and first I'm gonna make the selection. So it's here. And now I'm going to show you what's the result. So here I press Ctrl Enter, and the result is this little data frame that only contains the population in the year 2020. So this is important because the bar plot is supposed to show only the population in this year. So here we have it, and now what we're going to do is to name this data frame. So here we write equal to, and then let's give it a name. So I'm going to name it df_pivot_2020. So here I press Ctrl Enter, and now I'm going to show this new data frame. Well, again here, and here one little detail I have to tell you is that when we make bar plots, we have to put text data in the index. So here the name of the countries should be in the index. So to do that, we have to use the transpose method. So this transpose allows us to switch rows and columns and vice versa. So here we can easily do that by writing the data frame, the name of the data frame, and now .t. So if now we run this code, we can see here that we have this. So now the year 2020 is in the column and not in the index anymore, and the country names are in the index here. So this is the format we need to have before making the bar plot. So now I'm going to overwrite the content in this data frame. So I write df_pivot_2020 equal to this same data frame but .t. So here I run this, and now it's time to make the bar plot. So here I copy the name of the bar plot, and now I use the plot method. So I write plot again, open parentheses, and the first argument is the kind. So I open quotes and we write bar. So now it's ready and we can run it. So as you can see, we have a basic bar plot, and it has some default values like the name of this X label, and also the default color is blue. And we can customize this bar plot a bit more. For example, I want a different color, so I write the color argument and then open these quotes, and let's say I want it to be orange. So I write orange, and also we can change the X and Y label. Actually, I can copy this here so I can save some time here. So X label and Y label are here, and let's paste it here. So X and Y label, and finally I can add also the title, which was here. So I copy and paste it, but in this case the title is a bit different because in this case it's not from 1955 to 2020 but it's only 2020. So here I have only 2020, and now let's run this to see the results. So you can see here we have a title, the X and Y label, and the bar plot is in orange. So that's how you customize the bar plot. Alright, so far so good. Now let's go one step further by making bar plots grouped by n variables. So here we have to select a group of years to make these bar plots grouped by n variables. So I'm going to copy this code we used before to select only the year 2020. I'm going to copy this. And in this case, I'm not going to select only one year, but a group of years. So let me show you here. Instead of choosing only 2020, I'm going to show you the pivot table again so you can easily understand. So instead of choosing only 2020, I'm going to choose some other years here. So I'm going to delete this and I'm going to write it here. So let's say 1980, 1990, then 2000 and 2010, and well, finally 2020. So we have a group of years here, and we're selecting this using the index and is_in method. So here I'm going to give it a different name. In this case, since it's a sample, I'm going to write df_pivot_sample. Now I'm going to show you this one so you can see what this looks like. So now we have 5 countries and now 5 years. So now I'm going to assign this to my data frame. So df_pivot_sample. I run this and now we have this new data frame. So it's time to make this grouped bar plot. So here we write the name of the data frame and then the plot method. So we write that plot. And now let's add the first argument, which is kind and equal to bar. Now we run this, and as you can see here, we have the plots or the bar plots grouped by year. So here's 1980 and 1990 and so on. And you can also add the same arguments we added here. So for example, I can add the X and Y label. So I can do it here. I'm gonna do it fast. So here I run, and as you can see here, we modify the X and Y label. And that's it. That's how you make bar plots with pandas. Okay, in this video, we're going to learn one of the most common charts that we can make in pandas and actually in any other visualization tool. And these are pie charts. So before we make this pie chart, first let's give a look to the data frame we're going to use. And in this case, to make a pie chart, we're going to use the same data frame we used for making the bar plot because it follows the same logic. So here I'm going to copy the data frame we created for the bar plot, which is this one, df_pivot_2020. So this is what we created before by using the index attribute and the is_in method. So here I'm going to copy this, and now I'm going to show you here so you can remember what's inside this data frame, and it's here. So here, as you can see, we have the column 2020 and the countries are in the index. So everything is fine. That's what we need. That's the format we need for making the pie chart. But there is one little thing we have to modify, and this is the column name, because now it's 2020 and this is a number. It's actually, I think it's an integer. So it's not a good practice to have numbers in columns. So what we have to do is to make this a string. And to do that, we use the rename method. So we write that rename, open parentheses, and now we use the columns argument. So we write columns, then open these curly braces, and now we write the name of the column we want to change, which is 2020, and we're going to make this integer value into a string. So we open quotes and write 2020. So apparently they are the same, but the green one is an integer and the red one is a string. So now to save these changes, I'm going to write in place equal to true. And I'm going to run this. So now we can make the plot. Here I'm going to write the name of the data frame. And now I'm going to use the plot method. So here I write that plot. So the first argument is kind. And here I write pi. So The kind is pi, and now I run this. And here I forgot to include the y argument, and I'm gonna write it here. So the y argument is supposed to have the data. So in this case, I'm gonna show you here again the data frame. So the data is here in 2020. So we should write here 2020. So I'm gonna delete this. And here in the y argument, you write the column that has the data. So that's what we did. So now I run this, and now we finally have our pie chart. So here is the pie chart. So that's how you make a pie chart. If you want, you can even add another argument like the title. For example, here I can say that this is the population in 2020, but in this case in percentages. So write this, and now we have this title. So that's how you make a pie chart in Pandas. Alright, so far we made a pivot table and many plots using Pandas. And in this video, we're gonna learn how to export the pivot table and also the plots we made with Pandas. So let's start by exporting the plots we made with Pandas. And to do that, first we have to import matplotlib. So we write import matplotlib.pyplot, and then we write as plt. So this plt represents this matplotlib.pyplot. So now we run and we imported matplotlib, and now we can use this plt to save the plot. So we write plt.savefig, and now we open parentheses, and here we have to write the name of the file we want to export. And here I'm gonna write my_test.png. So this is the extension and this is the name of the file. And now before exporting this file, I'm gonna show you something here. So probably you noticed that when we make the plots with Pandas, we get these words here that says access, subplot, and all of this. So we can get rid of these words by using the show method. So we write plt.show with parentheses, and if we run this, we're gonna export this figure, and also we're gonna get rid of these words. So let's try. So I run this, and as you can see here, all those words disappeared. And also we exported the figure to a PNG file. And now this file should be located in the same folder where you have this Jupyter Notebook file. Okay, I'm gonna open that file, but first I'm gonna export the pivot table. So here I copy this df_pivot and I paste it here. And now to export it, we have to use that to_excel method. So we write to_excel, and now I open parentheses. And here we write the name of the file where we're going to export this pivot table. So in this case, I'm gonna name it pivot_table.xlsx. So this is the extension of Excel, and this is the name of this file. So now I run this, and now the pivot table should be exported. All right, now I'm gonna open the Excel file and the PNG file we created. So it's here, and here we have the plot we exported and also the pivot table. So as you can see here, the plot looks exactly the same as the one we created here with Pandas, and the pivot table is the same. So I'm going to show you how the pivot table looks, and here is the pivot table, and here is the pivot table we exported. I open it in Google Sheets and looks exactly the same. And that's it. In this video, you learn how to export data frames as well as plots.